Good evening. I'm glad you could make it. Right now, the red light of our mother star is shining down upon me. I'm ready to give you the best show I possibly can. Slowly but surely, I get them bugs ironed out. And it's time to have fun. I have a good show for you tonight. We have a nice chat with Ramon, Grouch and I about the PEMS. What is the PEMS, you might ask? It is plasma electromagnetic sky. Ramon is going to regale us with what he has learned in his research. So without further ado, I will give you a few tunes to give people a chance to show up, and then we'll get right into it. It's 3 hours long. Then after that, I have a reading of Chapter 4 from the Book of Venus, Worlds in Collision for you. All right, fasten your seatbelts. The marathon has begun.
you thought that I'd always be there. That's when you changed, became all strange, telling lies, criticize. I was waking, self-medicating, couldn't believe after all this time. You were hostile, I was exiled, a million miles away from my life. With love, with love, street love. Couldn't stay there, just a feeling. So it's wounded.
and the behaviors of plasma are extremely mysterious. They're becoming less mysterious, but we're still in the stage of trying to understand what the transmutation is. So when we talk about the plasma electromagnetic force. The big issue for unification comes in two things. Number one, everybody's been studying various parts of the unified force for 200 plus years, and when they discover it, then they get a stamp on it. It's their portion. This is what they did. They contributed to this, and it seems completely unrelated to this thing over here. And then somebody else comes along and they study this portion over here, and they get, for example, Van der Waals forces. They get that gets attached to them, or you got Birkeland currents, for example, and you got Van Allen belts. So everybody's getting their own portion of the unified force, and the other issue is scale, because you can be talking about masses of quarks and other particles and electron volts, and all the quantum people, they can lay dominion on that. And then these guys over here, they're literally lying to our faces. They're not even giving us the courtesy to tell us, because they're saying, oh, these jets are coming right out of this black hole. Well, I'm not young enough to not remember that a black hole is something where everything gets sucked in and not even light can escape. So what are you telling me now? There's the jets shooting out of this object. It's, of course, plasma electromagnetism, and it's coming out of a plasmoid. And these are different scales. I mean, the current levels are, as different as, pico amps compared to 10 to the 17 amps. And so you have different people dividing up based on what they see, what they study, what they're going to attach their name to. If this person over here studies crystal plasmas, it doesn't seem related to this person over here working on superconductivity. And this is the great fallacy. This is the great problem of unifying the field. And when Sapphire steps through to do their portion, they're trying to do good basic science and focus on this part. But as you're pointing out, there is it's missing clearly, maybe even more than just magnetism, but it's a huge part. And yet I don't fault them for it on account of, they should be capable. If we were in a country, and this gets to a different discussion completely on the topic that I'm writing about, and it's not yet out, but if we were in a country that still believed in itself and still was reaching for the stars, so to speak, they've demonstrated enough to warrant a $10 billion contract to create the next level and to build a facility the size of, the Mall of America. What they've stumbled onto, I guarantee you, China will. If they haven't discovered the videos yet, they will, and then they will take full advantage, because you're talking about in Chinese cosmology, by the way, in the Chinese sciences, transmutation is a portion, and I don't mean it in the Sorcerer's Stone kind of lead into gold alchemy kind of way. I mean that there's a character that means metal, and it also means gold at the same time. And when you study it in the mythology, in the metaphysics, they actually believed that the metal's exposure to the sun long enough would turn it into gold. And where did they get this idea? Probably Thunderbolts. So it's part of the wisdom of the ancient Chinese sciences. If they haven't rediscovered that already, if that isn't the motivation behind their fusion research, I would be highly surprised, because I think that they are aware, and they will take, of course, they will take credit for the structured atomic model. They will run with it, and then they will be the standard bearers of the new cosmology, which would be an absolute tragedy, considering the men who really did spend 20, 30 years, the Jurgens and the Arps and the Birkelands of the world, who spent 20, 30, 40 years and never got recognition. The Byfield and Brown. still not getting recognition after all this time. And we are going to lose that edge, and the Chinese scientists are going to probably end up with a lot of the credit, or some of the standard. I saw the article come out. Scientists finally have calculated the electric field of the sun. I'm like, oh, really? 50 years after? That's amazing.
I know. I was in that thing in the 1930s. It said the same thing, that scientists they don't know anything more about the sun than they did, and they've been studying it for over 100 years. And that was written in the 30s. Because they tried to affix it to their theory.
Yeah, it's a real tragedy, because the plasma electromagnetic cosmology has come, it's 3 different streams. The magnetic cosmology stream, I was talking with Gareth today about this, because he did his new video, Plasma and EU. And my take on it was that he is saying what plasma universe and what electric universe are up to now. What they have been by the men, the Donald Scotts and the Wall Thornhills, as we've inherited it. And now, let's say since 2015, where things have gone since then, this is the new world order that we're working on. But up till then, there were these different streams, and that's only natural, because you had different people. It's an interesting. I would like to know, if anybody's a researcher out there, if Isaac Newton read Gilbert's De Magnete, because De Magnete preceded him by about 70 years. And so I would be surprised, because of course Newton could read Latin. I would be surprised if he hadn't read De Magnete, which would beg the question, why, when he was describing gravity, did he not immediately latch on to a magnetic cosmology?
I know. Didn't he ever?
He would have saved us all a lot of trouble. He would have fixed that. Einstein would have never fallen prey, and his general relativity would have been within the purview where it should be, which is, general relativity should be coming out of the other equations, because special relativity was, transformations of Maxwell's equations. So general relativity naturally should have been flowing out of electromagnetism, but instead he went this gravity direction, and he had to create this cosmic constant, and it's a mess. It's a real mess, and some of it is where there are some good hard sciences that came about before we even had the atomic model. When you look at the history, we had spectroscopy long before we had the atomic model. So they had already decided what the sun was. It's a gaseous ball that's burning, and yet it just violates the thermodynamics. So I don't know how it has continued on to now, except for tradition. It sort of reminds me of the Kung Fu world. You get one guy, he's kind of popular. I'm not going to name any names, but you get a guy, and he's really popular, and he has this idea, and then he propagates that Kung Fu idea, and then eventually you get a video of a guy who's running full speed into a woman who's just breathing, and he has convinced her that she will be invincible, and he plows into her like a football player. It's sad to see, because of course she's going to be injured. That's where we are. That's the modern that's standard model. It's the guy plowing into the woman who's just breathing. And when you get that distracted, then of course there has to be a changeover, and plasma cosmology is going to be the mixed martial arts of the whole situation.
What do you think about magna hydrodynamics? Magna hydrodynamics.
I think exactly what Alvin thought, which is that it was incomplete, and that it did not describe plasmas completely, particularly double layers. People need to watch Gareth's See the Pattern, his 3-part video series on double layers, and take a look at the papers and look at the electric circuits. Alvin was a genius. He's part of the giants that we stand upon. But naturally, in a astrophysical, what the problem with the astrophysics community is that there's so many of them that want to be celebrities. They all want to be on Neil deGrasse Tyson. And
and there's so many of them. There's so many of them. What they what's the name prize? What is it?
The Nobel.
Should remember it. The one on. Yeah, Nobel Prize. That's what they're all hunting for a Nobel Prize.
Yes, and they're willing to cheat to get it, which is the scarier thing. It's a science. They're willing to completely lie. But that it may, because they're on the hunt for celebrity status, they're going to attach themselves to rock stars. And Alfin was a rock star, and magnetohydrodynamics is useful for a lot of things. And it's convenient for modeling. And now that we have supercomputers that can do pretty good fluid dynamical models, it's convenient, but it gives people the wrong idea about magnets, which brings me back to the magnetic reconnection. So in the Hawkins electric field guides from 1917, which I just bought a set of 6 off of eBay. There was another set. People should go look. The Hawkins electric guides are excellent. There's a very simple experiment. So it really helps if you have a magnet ball, but you could use any magnetic field as long as, of course, it's going to curve. And what you do is you take like a piece of metal. I used the handle end of an acupuncture needle. I just cut off the needle and then just had the handle. A person could use a nail and take off the head of the nail. And you magnetize it by running it across a bar magnet. You're scraping it across, and then you tie a string to the center of the center of balance for the nail or the piece of metal. It should be cylindrical, and then you just simply dangle this over it. Now, if magnetic fields were really lines, the piece of metal would jump between what would appear to be like valences. It doesn't do that. It has places where it prefers to move to, but it will move in a smooth fashion, and it will follow. So what you become aware of when you do this experiment, if you're paying attention, of course, is that the magnetic field is everywhere around it's not existing in lines. It is a continuous field with gradients of concentration in the magnetic flux. And technically it's not really flux, but that's a different story. So there's nothing to disconnect or reconnect. This idea is a real problem. It is convenient in the same way that light as a particle is a convenient model. Light is not a particle, but is a convenient model. But when you start seeing otherwise incredibly intelligent people, I mean, I was watching Action Lab, and he did a video on the photoelectric effect, and he kept talking about the photons knocking electrons out, as if these are billiard balls running into each other. This is how we know that the idea is wrong. I saw another really funny one. This is a professor, and he did a video for the Royal Society, and he was educating young people about the space-time and general relativity, and he put a bowling ball on this big sheet of fabric, blue sheet of fabric, and of course it weighs it down. And then he would spin the balls, and they would all... Now, here's the problem. Number one, he's defeating his own theory, because we know that, say, the moon, for example, is slowly escaping Earth's gravity. So it's not spiraling in towards the center at all. And number two, he's relying on Newtonian gravity to prove general relativity as a model for the students. And then the number three thing, of course, is the arbitrariness of up and down. There is no up and down in space, but there is definitely an up and down when you use a bowling ball on a piece of fabric. Mm-hmm. But because the visual demonstration is so powerful, people, they swallow it and they take it on and they move on for the rest of their life. They'll think that they understand space-time. Mm-hmm. But it's completely arbitrary because if it worked that way, because the fabric of space-time could be then put on a vertical, it could be put upside down in the picture, right? Why doesn't anybody just flip the picture upside down, the bitmap, just flip it upside down and then ask, well, why isn't this Earth falling from the sky? Why is it rolling in this framework? And the mathematicians will say, well, it's just a mathematical fabric. It's not a real fabric. Well, then it has no place in science.
They use Earth on gravity, right? Gravity on Earth, I mean, too.
Right. They use Newtonian gravity to describe why this thing should be rolling around a fabric of space-time gravity.
Mm-hmm.
That is, well, it's felonious, really. That's not science.
No
So we have a real problem with visual demonstrations like that constantly going around. I'll give you another one with the light particle thing.
Mm-hmm.
There is a video of the slowing down of light. So we've captured the light in slow motion, and they go on TED and they show this video. The light is moving through the bottle, and you can see it going through the bottle. It's absolutely beautiful. Here's the problem with that. If you could see the pulse of light of photons moving through, then in every reference frame, you should see the photons then also moving at that same velocity, correct? I mean, that's how slow motion works. If you watch a slow motion football play, the football and the player are both moving at the same slow rate. You know, one is not suddenly going full speed and the other one is moving in slow motion. But when you watch, the light is reflecting off of the desk, and there is no pulse moving between the two and bouncing around. And as it goes through the bottle, it bends and reflects, and it's immediately on the table. Do you understand what I'm saying? So if you're watching the balls of photons moving slowly through the water bottle or Coke bottle, I think it was,
Okay.
then how is it getting to the table without moving that same slow speed? Why is it instantly on the table reflecting?
Mm-hmm.
For that matter, why is it also, getting to the camera without? So there's and they gloss over it because it's such an amazing thing to see light move that slow. That you don't even stop to go, well, wait a second, this is actually showing that light is not a series of particles, which we should already know anyways, based on, how it slows down instantly as it goes through different media. We have this problem. It's all throughout the sciences. And I don't know who to blame. It's easy Ken Wheeler loves to blame Einstein. But I think Einstein even had a problem with, I don't think he liked being a rock star celebrity. I don't think ultimately I think it gave him grief.
Yes.
But that's just my thought.
From the letters
the
between
state of
Velikovsky and Einstein, Velikovsky had said that he was very forlorn in his older years.
Velikovsky said that?
Yes, because of it, yeah.
Yeah.
Because he got treated like a rock star everywhere he went. And he didn't.
Yeah.
Dogstar said, watching your show now.
Well, he got to the point where he was narrowed in on that where he got to, and if he went further and then what he'd previously done proved not to be total as everyone wanted it to be, well, then they'd call him a fraud and everything. So that's what happens when you become a rock star. You can't.
Go ahead, finish, Grouch.
Yeah, you can't be open anymore. Yeah, you can't be open anymore because if you start going, well, I got to there and then I went to there and now this is what I got, then they say, oh, you're frauding us or whatever. So that's really, they pigeonholed him.
Yeah, I think that it wasn't Einstein's fault that he had a lot of celebrity status, and I also don't think that it was his students' fault that they admired their teacher. I think it was the students who became the zealots. And then by the time you get to the era of the heyday of Stephen Hawking, it really was out of control.
Did you know that? I'm sorry. I thought you were. I was going to say, did you know that Stephen Hawking said there are no such thing as black holes before he died? Black holes do not exist.
I had heard that. I hadn't really looked into it. I'm not as interested in Stephen Hawking's work on mostly on account of when I listened to what he had to say, I wasn't as impressed. And I'm not saying that he wasn't a remarkable individual, but you know, I think it's another example of somebody, they spend all their time in a certain track, and you know, they end up being kind of stuck in that rut, and they're not able to jump track.
Yeah, he had a famous feud with another physicist. I can't remember his name. But they had a feud over black holes, and before he died, he claimed that they don't exist.
Yeah, well, I mean, you know, now we know they don't. But they have more existence to them than dark matter and dark energy. That's for sure. And those have more existence to them than the plethora of nonsense that's now coming out. I mean, we have opened the portal of absolute horseshit when it comes to pseudoscience getting grants. These people are coming up with anything in order to try and get the big money. So they can talk about dark, you know, fluffy darkinos and axions and
Wimps.
you know, and dark photons and
Machos.
Machos and dark, you know, charged dark matter. I mean, the one thing that has turned out to be real is the Bose-Einstein condensate. But I really think that it's going to be some form of ultra cold plasma ultimately. The various forms of plasma that are out there. Imagine you get into the field of plasma research, and actually there's an entire array of types of plasma for you to study from. And there's just not enough people doing this kind of research. We don't have enough manpower to do all the research on superconductivity. The superconductivity field is really exploding. We are now at the point where they are coming up with superconductors.
Paul from Iraqi said, because you say here it is,
that is
photo proof, and it's an illustration,
amazing. And
it says so on the video.
That's interesting because it's also happening concurrent with some interesting things in chemistry, such as the ability to melt gold at room temperature. So when we look at this, an engineer friend of mine and also entrepreneur, we want to work on the puttification of stone, because I think it's very obvious that the stones, at the Inca stones, for example, were not polymers, but were somehow electrified, and that the crystal lattice lost the structure without getting too hot either. And you can see these where they must have attached, you know, two electrodes to each of the stones, creating what appear to be handles. But we can tell that they're not handles, because there's several of the stones where they're not, you know, level to each other, and they, you know, there's no way to really use them as rope handles. They don't stick out far enough. So why is it so common? And also, it would very succinctly explain how you get these stones to sit on top of each other and to be so tight with one another. You turn them into putty first, and that's why there are these places where there are stone looks like it's been cut out of the rock as if you were cutting putty or cheese, and that's probably because they were able to electrify it. Which brings up the other question: where was the energy supply? How did that work? You know, Neil Thompson is the only person I've seen come out with a convincing argument for that. Trying to get him to release that presentation again, that slideshow presentation again. So hopefully he does. Certainly I would like to personally step through. My partner thinks it's some form of microwave.
Is that Neil from Electric View?
From the Electric View, yeah.
I'm about to talk to him. He wants to do an interview.
Bring up he can explain the theory behind it. I don't know that anybody's ever done it yet.
It's more like
electro-geology and lab and people's garage still seems to be about arc discharge. Everybody's really, they like burning things, which is fun. But that would not be how the ancients, you know, what they were trying to do. They've been trying to change the crystal lattice. But it had to be low temperature too, because we have the vitrified stone where someone put their hand into it. Of course, the ancients believed that he attained this electrical, mystical power and then melted the rock. But either way, however it happened, it had to have been low enough temperature. It couldn't have been red hot. So if we were to put high arc electricity into that, thousands of volts, it would of course heat up quite a bit, and you wouldn't be able to put your hand into it. So and then how could you build a wall? So I'm interested in that. I'm interested in
So Ramon, you've got to get the volts about the amperage. You've got to get the volts
Yes.
about amperage, basically.
That's right. And
Would that be a simple person's way of putting it?
I'm sorry.
That would be a simple, not simple as in simple. That would be a lay person's way of putting it. I need the voltage, but I don't want the amperage that goes with it.
Right. But that brings up the question: who in the BC era was creating? I mean, were these super Baghdad batteries? Who is creating DC current at that level? And the other thing is, how are you getting the puttification of the crystals to happen all through the stone and not only between the two electrodes? This is another interesting engineering problem. But obviously, the ancients solved this issue, and I think it's a pretty good proof. Whoever built the Egyptian temple, the Egyptian pyramids, was able to get around the world quite a bit, including down there to Australia. And they were bringing this knowledge with them. There is stories of Veracochans with, these power sources that they carried around with them. And if that's possible, did they maybe actually destroy their own Atlantis? Who knows? I mean, there's a lot of things that come up, and it's potential big money. I don't see how Sapphire could not become massively invested in. It really should be.
Yeah. What are your thoughts on?
Yeah, I quite agree.
What are my thoughts on what?
Magnetars.
Well, I think that they're probably a form of pinching with extreme magnetism. I think it's probably as quote simple as that. I do not believe in neutron stars, let alone ones that can spin. I had somebody write me in my academia, and everything was neutrons, and you needed nothing else. And I thought, well, that doesn't work because there are so many things that are charged. Mm-hmm. How would you get these things to want to compress? They don't even want to be around each other in the first place. So you need protons in between neutrons. So now, how are you going to get them to press down? And then you have them spinning. We know there is a limit when you spin an object that at some point it basically tears itself apart. So I don't believe in neutron stars. I think that was always someone's best guess. Mm-hmm. But that a magnetar is a magnetic pinch. It's a very strong pinch.
Yes.
Probably as simple as that. It's quote simple.
They're calling pulsars now.
Well, the pulsars are the magnetars. Their primary feature is the magnetic fields, and the pulsars are radiating, X-rays and gamma rays at a high rate. But they're both, described as a form of neutron star. If there's an astrophysicist out there, don't kill me over that. This is not an area that I study very often.
Don Scott calls them relaxation oscillators. Like a spotlight.
I think that a lot of these kinds of pinches are going to come down to various forms of circuit behaviors, and it may be variations of how the material is working, but it's going to be some kind of lattice, and that lattice is going to behave like a condensed matter plasma. I couldn't say it'll be a crystal plasma. Robitaille has one condensed matter plasma paper, and I would love it if his channel on Sky Scholar, if he would bring that back up. So people should go and read his condensed matter plasma paper. It's one of his older papers. But
who's that now?
Robitaille, Pierre Robitaille.
Okay.
So on his, I forget the name of the PTEP Online, I think,
Links
is
to what
the
he talks
first
about
site.
are in
All of his
the
papers, and
description.
if you scroll down to the third or fourth from the bottom, he has a condensed matter plasma paper. The world of the liquid metallic hydrogen is going to get combined because charge is everywhere. It's the ubiquitous thing. Neutrons even can be divided up into two different forms of charge, so that are existing in a very tight relationship. Again, the concept of scale, the plasma electromagnetic force changes its behavior depending on the scale. And so this is going to account for the difference in power or force level between the strong, the weak, and the electromagnetic force. It's really all one force. Hello? Okay, just making sure I'm still there. I had a call drop the other day when we were when I was on Rex's show.
Yeah.
So at any rate, I hope I answered that.
Yeah, no, that was good. Yeah.
No.
Go ahead, Grouch.
No, I was just interested because I listened to your discussion on Rex's show, and it was sort of billed as clash of you and Lou were meant to be at opposite scales, but my view is you ended up agreeing on a lot more than you disagreed on. Would that be fair to say, Ramon?
Oh well, absolutely. I don't have any. I didn't know Lee before that call.
No.
I think he has he has his disagreement with the mainstream astrophysicists about what us. But it turns out we both already agree about that stars are electric and all this thing. So, it was just the star thing that's up there. But for the most part, I didn't find any disagreement with him. I don't think he's completely aware of my research on Shamash, and I don't blame. That's no one's fault. We're talking about stuff so cutting edge. I mean, I need to finish editing that paper. I will admit I've set it to the side to write these other papers. Part of that is that my scans are kind of missing in the clinic. the data tables are done, but the scans are around. The paper is kind of ready for edit, and it has the animated GIF files, so where you can see the three-body problem of the star pulling apart and all this kind of stuff, as best as I can do, considering I am not an animator and I don't do this. So I had to find examples to show the visualization of what I'm talking about. And since I've been writing that, it just more evidence keeps coming up. I was just watching the Diehold guy, Vogt, I think is how you say his last name.
Yeah. Yeah, I know who you're talking about. Yeah.
He's giving quote after quote, and he's interpreting them by micronova. But I'm reading them. I'm going, well, this goes exactly to what I'm talking about. The death of the previous star, and I love it. There's so much evidence now pouring out that is in support of the breakdown of Shamash that I'm actually.
Hello?
Yeah. I listened to most of John Vogt's, a lot of his presentation, and you just got to sort out, because at the moment he talks big about we've got to prepare for a catalyst in 2043. Is it, Ramon? I don't know if you've come across them or not.
Well, let's say.
You there?
I'm sorry. Finish. Go ahead and answer. I got a thought that I don't want to forget. Go ahead.
No, I just think it's funny because, number one, these guys, whether it's Ben or Vogt, they don't know that the planet turned over less than 7,000 years ago. So even if it was a 12,000-year cycle for several thousand.
But in one of these, he does talk something along that line, but he talks about the Earth stops and changes rotation.
Yeah, well, it doesn't really change rotation. It's just sort of the angular momentum keeps it going in the same direction, but it's turned over.
Yeah.
And that happened before. It did happen, but their mechanism is not proven. What we do know is that we were in Jupiter's magnetosphere, and then we moved to Sol's magnetosphere, and that's probably accounting for the flip. There could be, though, this mechanism of the asymmetry in space probably has a portion to play as well. And I give more credence to that and looking at the wobble that we're having now. But there's no call to say that we can say that in the next 10 to 20 years it's going to absolutely happen. That doesn't mean I don't have my plan in place in case it does. You know, you think of when you read Revelations, I will come like a thief in the night. And it's like, well, I certainly, because if the sun's down, you're not going to notice that it's not up. You know what I mean? And you're not going to notice that it's not acting funny. So I think about those kinds of things. But as far as a scientist would speak, you cannot know the future. You can make hypotheses about the future.
I'm going to tell you something. Speaking of that, this is right in line with the question I wanted to remember. Now, for the last couple of days, during the last hour or two of the sun being up, the atmosphere was configured in such a way that you could stare right at the sun and it didn't hurt your eyes, and you saw it just like a big orange rubber ball. And at night, for the last 2 nights, we've had a blood moon here in Michigan. Do you make anything of that? Is that some kind of telling sign of anything to come?
I do make something of the fact that it's been difficult for cellular networks to work, and for people, and that a lot of my patients. So I don't know if you're familiar that much with my medical research that I've done in clinic.
No.
But there is a strong correlation between protons or various forms of heavy material in the solar wind and an increased response to the acupuncture. So people have a greater change in their electric field. When I measured their electric field and divided that by their change in pain, the ratio was a stronger change in electric field to change in pain ratio when there was a greater electrical environment. So either cold wintry day or bright sunny day or a new moon or a full moon. Mm-hmm. And all these are conditions when you have an excess of proton activity. Protons are yin by nature, right? They're supposed to be the ones that are negative charged, but that's another story, right? That's Ben Franklin, electrical engineering history. But protons are yin by nature. It's very difficult for the body to deal with these extra charges. Basically, the charges become lodged in the nerves and channels, and they interfere with the circuit. So I came up with a model called charge distributive networks, and it is an electric circuit model. It's actually kind of a fractal model based on the work of another EE acupuncturist out of Taiwan. His model was a block wire diagram with a Y diagram, sort of like a 3-phase diagram, but his main concept is the fractal wave function of these channels. So I needed the entire channel, and I needed the acupuncture points themselves to behave as transformers primarily. But then you need a source on one side, and you got inductance, you got resistance, capacitance, you got these various measures of the body. And the model I came up with, encourages propagation down the channel, but it doesn't have to propagate. It could theoretically go in reverse against the Zener diode. And why do you want that? Because we know that there are things that counter flow. For example, gangrene. If you get, I have a gruesome story for you. I have a patient who lost both of his legs, not because of me. He went to another acupuncturist who shall remain unnamed. And this person thought that they were a genius of ancient classic knowledge. And they needled him above Tai Chong, and they angled it up. They did strong stimulation, peck and thrust. He went into a spasm and they left him on the table for an hour uncovered, shivering. So his chi totally reversed. and he developed wounds as if he was a diabetic on both of his, well, above liver 3, really. And they rotted. I tried to get it to go back, but it, you know, as soon as you start getting the signal going back in the right direction, he has to go off and work in construction, and so he's wearing these boots. He's getting infected, winds up losing both of those limbs. To this day, he still gets rocked in his trigeminal nerve with these vibrational attacks that give him like a seizing pain in his face as the counterflow signal tries to essentially hack into his brain. This is very ancient medicine. There's nothing new about that. But the main point is that you have to account for a backwards mechanism, whether it's gangrene or something as innocuous as shaken hand syndrome, which usually comes from people running jackhammers or something. But there was one kid who got it from playing PS2 too much and had the vibration controllers. He was like Japanese, and played it like 20 hours a day or something.
Damn.
And so, you know, you have to, you know, have some mechanism for these signals to flow backwards, whether they're fluid signals or ion signals. There has to be a mechanism. So the Zener diode prevents most of the signal from returning across the transformer, but it enables it. It's possible if you have too much voltage on the right side of the transformer will transform backwards, and that's what disease really ends up being. So
what you're saying is like, I don't know much about that, but it's basically like you turn the body into a generator and start taking energy out of the body is what happens. Would that be a fair?
Yeah. So what the
So the idea of acupuncture, as I understand it, is you're putting energy in through the needles that puts energy back in, which is the electric
not so much puts man, but
is that right?
You end up freeing by pumping out some of these protons and other charges. When you clear the channel, the transformer works more correctly, and then you have a stronger signal in the positive direction, so-called positive direction, right, left to right in the diagram. And when the body gets full of these protons, when it gets too yin in nature, it doesn't function well, and the consciousness doesn't function well. And this stuff is so predictable. I have an interesting story here. So I did a show on Catherine Kaufman's channel. I did an Electric Universe show on a Monday night. That night, a strange storm moved in. The next morning, there was a large amount of what's called the killing chi. And I was driving down the highway to go to my clinic, which was in another city. We've closed that clinic because of the COVID and everything. And there was a bolt of lightning came straight down, and it was a long enough stroke. I watched it actually dissipate and form the little balls of plasma as it dissipated. So I was like, oh, there is a lot of killing chi today. And then I started noticing it was trucks. And so all these different trucks were it felt like I was trying to be killed here. So I pulled off at the gas station and I just let all that energy go by. And then I went to work and everything was fine. I heard then later on in the week that my former master's wife that morning was hit by a cement truck. She didn't die that day, but she did die eventually from infection in the hospital, or I think maybe a clot was thrown or something like that. But she was hit by a cement truck that same day. So how did that happen? You know, we would go back to the plasma cosmology. There was too much of this yin type of energy in the air. The cement truck driver was affected. Maybe she was affected. There's some kind of distraction. Either way, their charge distributive networks were not functioning correctly. And, you know, it was a dangerous day. It was an absolutely dangerous day. And it wasn't purely about rain or anything. But, you know, you can hear on these kinds of days, you can hear more sirens. And again, going back to the new moons, full moons, it's well known that, you know, psych wards and hospitals have an upsurge in psychiatric cases. and I would say there's probably spikes in suicide attempts, and other situations like alcohol abuse, when we have more of this yin. So as the magnetosphere drops, people are getting more exposed. They're feeling more yin, and in this case, it doesn't mean female. It means consumed. It means disrupted. Yin can also be a form of division. Yin is kind of an upper category, and there's lots of different things under yin. And there's true yin and there's false yin, but that's a different story.
Man, you've got so many papers here, Ramon.
Yeah. Have you seen? Did you? One of my favorites is the newer one. Of course, I did the 2 trip reports.
Are they new by top or bottom?
Top is the newest ones, yeah. Okay. So going up from the simple guides for friends, family, and common folk how to get into crypto. You have the trip report to the Culvertown platform. That was cool. So we had a drone flyer come out, and his drone. He's a professional drone flyer. His drone, and the quote is in the paper. Got zapped. It got electromagnetically pulsed at 400 feet above the knob. And remember, the knobs of Kentucky are electro-geology formations. We know this because you can look at the knobs near to Houstonville, Kentucky, and it's a Lichtenberg formation. They're all at about 950 foot elevation, except for 2 main knobs. One would be the Green River knob, which is the anode in that region, and then when you arc around, then you have the Pilot knob, and it's an anode. And in fact, it looks exactly like the Pilot knob in North Carolina. They're roughly the same kind of shape. I think that the one in Kentucky is 1,000 foot shorter, but that might be a continental shelf thing. So, the knobs up near the Culvertown platform, which I was there because I think it's a Saturnian egg. I think it's a 9,000-year-old egg. And people, when they click the paper, it has the tour. You can, it's a beautiful tour. Three-dimensional tour. But I think that all those knobs were sputtering arc discharges of the same event. Now, interestingly enough, if you follow the curve, so Kentucky's one big dome, like the center of Kentucky is a dome technically. It's a very large dome. If you follow the arc around the bluegrass and you follow the knobs around, you end up at a crypto explosive electric site called Hicks Dome. It's in the south of Illinois, and in fact, I'm going there this week. I'm going to go camp at Garden of the Gods because I found the Garden of the Gods discussion that I've done with Rex and his friend. Oh gosh, what's that guy's name?
Not Diamond.
Diamond.
Yep. Great nice Diamond.
Yeah.
And Dave? Yeah.
And I talked with them about it. That's in the trip report on the Pebble Beach. So at the end of that trip report, you can see the same Garden of the Gods evidence that I provided. Well, I'm going back. The reason I'm going back is there is a platform also at the Garden of the Gods, and I want to camp there. There's an interesting energy to the whole place for sure.
Isn't there 2 of them? One's out west and one's in Kentucky.
Yeah, but it's Illinois. But
okay.
The Garden of the Gods in Illinois is on the edge of this crypto explosive event called Hicks Dome, and the geologists try to say, this is all in the trip report, but they try to say that it's a volcano, an ancient volcano, but they don't have a gravity anomaly. You know what they have? A magnetic anomaly. So they have this huge magnetic anomaly, and then they want to talk. Of course, they're going to blame it on the iron. The question, I'm sitting there going, okay, well, why is it there? Because you can look at it, you can see it's got a bow shock. It's only on one side, right? This is not a volcano. So now it's at the end of this arc of Lichtenberg knob formations in Kentucky that go around the dome, and that is the center. Now remember, in that dome of Kentucky, in the bluegrass region, is a Paradian Thunderbolt. Why was that Paradian Thunderbolt from? It's an octagon, 56 craters. Why was it attracted to that dome? Probably because it's always active anytime there's something going on. So we're out there measuring this Culvertown platform, and we're taking pictures, and we send them over the knobs, and it gets EM pulsed at 400 feet above the knob. And 400 feet is that's quite a bit of distance as far as electromagnetism is concerned. I mean, I don't know what kind of flux was coming out of this knob, but the drone barely made it back. The link to the YouTube video for the flight over is in there. You can see the moment when it gets pulsed. It is not even over top of the knob yet. It's almost over top of the knob. So that's in that trip.
Who did that video?
Go ahead.
Who did that video? Who did the video with it getting pulsed?
Oh, his name is Isaac Cooper. He is a professional.
No, what I say is, yeah, but you haven't uploaded it yet.
No, it's all uploaded. Yeah, and it's all uploaded. So when you scroll down the trip report for Culvertown, it has the virtual tour and the video tour. And then the Pebble Beach is the one that has the Garden of the Gods photos. So those are the two trip reports that I did fairly recently. They're short little papers. I think that people will enjoy. The Pebble Beach was fun. The reason why I made the Pebble Beach one wasn't to talk about the Garden of the Gods specifically. It was to talk about the fact that at Pebble Beach in the Red River Gorge, I found this stratification in Figure 1 on page 2, where you have changes in the angle of the layers of this, supposedly ancient sandstone, basically what were sandbars in the old, dinosaur days. And then it changes to an angle, then it goes back to being level, then it changes to the same angle again, then it goes back to being level. Well, I found the same thing 60 kilometers away at Dogfoot Hollow, and I've got in there the coordinates and what date they were taken and everything, and you can see that this is not making sense from a uniformitarian perspective. And by the way, the Dogfoot Hollow we were there for archaeological reasons, because we're looking at it as a potential potential stone fort because of the particular pieces that were found that are on page 4 of that trip report. That's why we were there. We weren't there for electrical universe stuff. And but it happens to be on the same ridge that there's a little gap, and then you have the Indian Fort Mountain. Of course, Indian Fort is infamous because it's a stone fort of the Fort Ancient culture. And people thought it was Vikings for a while, but it was not. It was, these Welsh, the Nikotani, as the character called them. And guess what's right across from this Lichtenberg called the Indian Fort is the Pilot Knob. So Pilot Knob, and then the Big Hill Ridge where Dogfoot Hollow is, and the Lichtenberg, known as, which is where the supposed vortex. You know how some people say that Sedona has a vortex? Well, Berea is known to have a vortex as well, and it's because of the Indian Fort Mountain where the Lichtenberg is on that part. It's not the best Lichtenberg in the Knobs region, but it is one of them. And right next to those is Pilot Knob, and Pilot Knob has again this very interesting anode type formation. It reminds me of. Basically, if it were enabled to continue, it would end up like Devil's Tower.
What's it called again?
Pilot Knob. So there's actually 2 Pilot Knobs in Kentucky, but the one that I'm talking about looks like the Pilot Knob in North Carolina. And so
elevation in those
we're talking about 900 feet. The Pilot Knob gets up to 1,200 feet. 1,200
from ground level.
Oh no, from ground level. It's surprisingly steep hiking. But so if you were to go from the highway up to this rock where it's changing angle and then going flat again, changing angle, going flat again, you're probably talking about 250 feet of
Athens
climbing.
said,
Same thing with the Pebble Beach. And obviously the Pebble Beach is the same elevation, but they're 60 kilometers from each other. And they have nothing to do with faults. There's no fault that's connecting the two. It has nothing to do with upthrust at all.
You know, one thing I noticed about the Garden of the Gods is it certainly is unusual topography for the Midwest to be that rocky.
Yes.
Yeah.
Well, but you see it's at the edge. You see it's at the edge of that Higgs dome and that crypto explosive event. And I think that it was the bolide splitting and electrifying, but it could be a burn. You know, the question is then now that would present a new challenge, probably not to Andy Hall, but in general, probably to the electro-geology. How do you create a bow shock with this arc discharge? I'm not saying it's impossible. That's not my particular region. You know, that maybe more Billy Elverton's goal. He may have examples of bow shocks. But how do you create it to where it's an asymmetric situation where it's not happening on the other side, and then that would create no problems.
Mm-hmm.
It's obvious that there is a strike here. I mean, you look at Figure 7 on page 6, and you can see which direction it had come from, and where the blast occurred.
On your paper?
Yeah, in the trip report there.
Which one is it?
The Pebble Beach, the
Pebble Beach.
Yeah.
Oh, I saw it. Yes, fine.
Yeah, so on page 6, you can see the Higgs dome.
Oh, okay,
Again,
that's good. All right then.
I go into this
Just click
because
on it?
the geology.
I that one, yeah.
The geology is so similar between the Red River Gorge and the Garden of the Gods. That's why it's in here. The Lysagang or Lysagang banding is happening in both places. It's more pronounced at Garden of the Gods, but it's in the Red River Gorge as well. Well, it's in the entire Daniel Boone ley line.
That's interesting.
And again, the Higgs dome is at the edge. The Higgs dome is on the other side of the Ohio River from Kentucky, and it is there are knobs banding all the way around the dome of Kentucky. So it appears to me to be one huge event, and I don't know if it's related to Andy Hall's formation of the Southwest event, or if it's a completely different event. Greg, the picture on page 8, the figure 9, shows the polarized behavior that it defies. It completely throws the uniformitarian explanation out the door. That is not possible, because you can see the line of material going from the bottom of the picture towards the top of the picture, and the complete the change of the polarity and behavior from the right to left side of that band, and then above a certain point where suddenly the banding is ceasing, but the line is continuing.
It seems to me that this is two different substances, like this maybe got thrown on top of this.
It didn't. But back to my point, there is a platform at the Garden of the Gods that it looks like a hexagon on one level and an octagon on the next level, and I'm thinking that it may have been shaped by the natives in order to first give witness to Saturn, and then to give witness to Jupiter. And I'm going to measure the segment lengths and take a look at the angles and see if there's any ratio congruence between them. Particularly the octagons, because of my work with the Jovian octagons and the Hopewell sites, which I'm not going to lie, I'm extremely disappointed in Graham Hancock, because he looked at this basically, and when you look at the Jovian octagons, it is a lock and key mechanism. It's literally they're asymmetric in length and in angle, so you can you can find any octagons you like and try and fit them. You're not going to be able to get it to work. Well, to get them between the two, to get them between the mounds and the vortices Jupiter's North Pole. And so it's just a little disappointing. And I thank him, for at least, he's inspired a lot of work. It's sort of like Dave Talbot and Wall Thornhill and all those guys. Very inspirational. But it's a little bit frustrating that he's not willing to take, because it throws the Zamora stuff out. And I think that you and your audience know that Zamora is, taking a very narrow perspective on what happened to the megafauna. If there was a comet, it was a small part of the show. Mm-hmm. There was a lot more interesting things going on. And anyways, the excuse he gave was kind of disappointing, because look at this rock. I mean, this is fascinating stuff. Any geologist worth his salt would look at this and go, "This isn't right. We can't. This isn't explained in the typical fashion." And it's right in the entrance. If people are willing to go to the Garden of the Gods and just go on the sidewalk tour, just the normal sidewalk, I didn't have to go way off trail, and it's right there towards the entrance. So it's been sitting there waiting for somebody to discover it. And I'm starting to think that this electro-geology is even more common than we were, thinking before. Sometimes it's going to be a little difficult. On page 9, the final page of that trip report, the Pebble Beach, is again Dogfoot Hollow, and there's these salt veins, and they even look electric, and looks burned.
Absolutely.
Okay, that's the only example that I've ever seen in the entire Daniel National Forest. I'm not saying it's the only one there, but these soda veins, where do they come from? Why are they there? I think it's an example of some form of transmutation. And
they've stayed locked up for a long time.
I'm sorry?
Ramon, and they've stayed locked up in that for a long time.
It sure has. And it's about the same, like I say, it's about the same level.
Correct.
It's about the same level as those rocks that have these strange angles, and then they go back to the flat, and then they go back to the angles.
Hold on, I gotta.
Now I don't know the Garden of the Gods, the Higgs Dome elevation. I'd have to look that up. I don't know if that's at 900 feet or not of elevation. So they may not be. You can see what the geologists have to say on page 6 there. No shock indicators, a dome lacking in ring depression and razor ram, no gravity anomaly, magnetic high centered, at 6 miles northeast. I don't know. It seems like it's right in front of them, but at the same time, I realize it's very difficult for some people to make the leap. But I don't know why it's so difficult when there's so many natives around the world, and then there's so many myths in our own culture that basically say exactly what's going on.
It really does. Even just looking at it, you can tell that some kind of an event happened.
Yes.
I mean, look at the surrounding areas, how tortured it is.
Exactly. Exactly. And that is a hallmark.
But you'd also say that to the left of the screen, it's been a lot of water through there at one stage.
Oh, absolutely.
Electricity.
Looking at what Beg's got up now, you'd say the left of screen, looking at that, you'd say, geez, there's been a lot of water through there working that.
Yeah, the entire area, at one point, the entire area was on the equator, according to standard geology. Certainly, the Daniel Boone National Forest ley line, going from Tennessee up to Ohio, there are places you hike in it, and it really does feel like the Yucatan, or you can even feel that primal, almost dinosaur era feeling. It doesn't feel like any of the other temperate the temperate forests around.
Mm-hmm.
And there are places where it attracts increased rainfall without having an increased elevation. So you don't have suddenly an extra 1,000 foot of mountain, and yet there's more rainfall. It's one of the unique features.
Yeah, I can understand that.
Interestingly,
because where we live, we're in this little valley, and we're meant to get the equivalent of 16 inches more rain a year than everywhere around us.
So that would
And then
indicate
if you head towards,
Go ahead,
if you
Grouch,
head
I'm
towards
sorry.
St Arnaud, if you head towards St Arnaud from where I am, it's a little place there, and it's probably about 30 miles from where I am, and it's the same. You get a really good wet patch in there, and it's beautiful country. And the rest of it's all that hard hole gold mining stuff, clay, and that. Anyway, keep going.
Well, that would tell me that how much rainfall an area gets would depend on the amount of charge it has or something
That's
to that
exactly
effect.
what I'm thinking.
Mm-hmm. Yes.
I'm thinking that Australia's problem for most of the continent is that it's still recovering. And this is the same thing with the Sahara. And they both have a extreme burn mark. One is an anode, you have Ayers rock, and the other one has a cathode and the Rakat structure. And I don't know if those two are the same pair of anode and cathode, but we would need to look. Now, in America, I think that the cathode, at least the largest one that I've seen, was probably the Black Hills, and then the Devil's Tower was the anode at the same moment. In China, it appears that Wudong Mountain was the cathode, and I think maybe Mount Tai or I'm trying to remember. There's an anvil-shaped mountain there. I think it may have been the anode. So, these would then be from the primal era. These wouldn't be from the Clash of the Titans era. I don't know when Andy Hall's thinking that his event happened. And then the people who get into the Great Lakes being one large thunderbolt that excavated the region, the Great Lakes of North America. I don't know when, but the larger, the more primal is what I'm thinking. Because when we look at the Paradian Thunderbolt that's in Kentucky, it is big, but it's only a mile wide, and it's a single pulse. And it was generated by the magnetospheres rubbing and inducing current in the plasmasphere. So this is not an arc discharge. So what was it that was arc discharging? I think it was a star. I think it was Shamash. And so we're going back to the primal beginning. It could have also been the moon, because the moon has obvious electrical excavation on the face that's facing towards the Earth. The rest of it looks like a Jovian body, but facing the Earth, there's a lot of excavated region revealing black dust.
I've often wondered if that ice that came down through the Great Lakes and all that from Canada, what were they talking about? 2 mile high of ice melting in a very short time. I often wondered if that actually melted from underneath. So it wasn't,
Maybe.
On top. It was the Earth, its electrical core either got a voltage spike or lost, and it basically melted the ice from underneath, not from the top, and then sent it all, boom, off it went on its run.
Well, it's possible.
What they call that? 12,500 years ago event. What they call it. I've heard Randall Carlson talk about it a lot, and a few others, and it is very interesting. And I've often wondered if it actually melted from underneath through on talking on the electrical system. The sun had changed, and that changed the voltages in Earth, and that caused that possibly underneath. Yeah, go, Greg.
I just wanted to point out one thing that I noticed that's kind of uncanny. If you look at all the lakes in North America, they all lined up. It's almost like something bounced through. You know what I mean? Well, it almost looks like, I don't know, like a charge or some kind of huge thing of electricity just went bam, 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 bam. You know what I'm saying? All the way through. I mean, why would they be in a straight line like that?
Well, I mean, that again goes back to the point. My point in the megafauna extinction paper, I make 2 points touching the things you guys said.
Mm-hmm.
The first is, and in the new addendum paper, I promise I will get it finished. It's a big update to the megafauna extinction by Thunderbolts. The first thing is that the moon is not, people have this imagination that the moon is going around this nice orbit around us. That is not how it is. If you look at a map of observations of the eclipses go in all sorts of directions. This moon is going around, and it's predictable now with computers. We can predict it, but it was so chaotic that the Chinese had a very hard time. They had very complex mathematical models trying to figure out how to predict the movement of the moon. That would be one thing. And then number two, I did the calculations on these Thunderbolts, and you needed something like, don't quote me, quote my paper, don't quote me. Something like 6,000 to 10,000 of these Palladian Thunderbolts, single pulse now, not even continuous pulse, but single pulse, to boil Antarctica. I mean, when you talk about the levels of energy.
Mm-hmm.
So when you look at the Hudson Bay craters, they're massive, number one. And number two, if they had to go through 2 miles of ice, these craters would not exist. And if it had enough heat to get through 2 miles of ice and still make these massive craters, the whole world's life would have ended. It wouldn't have just been some megafauna and a few animals in the northern pole. It would have been a problem worldwide. So Zamora and Carlson and them, the problem they have, how do you generate that kind of energy without wiping out the world? And how do you be selective? Because a comet cannot be selective. Megafauna and step potential can be selective. By the way, a patient I had today knows a person who died in step potential this last month, I think she said, or last week, something like that. He got out of his car, and there was some kind of short in his yard, his own yard, and he died from step potential at his own house. Wow. The child was injured, but lived. The wife got out, but then for some reason she didn't. Maybe she was wearing high heels or something, but she did not suffer. But he actually died from step potential. So it's not like an ancient problem or something. This is a modern, potential thing that can happen. And he never touched any power line. Right now, you take it's in my megafauna extinction paper how far these things can propagate. I'll find the page here. First of all, you'll have to scroll down. The megafauna extinction paper has been around for a little bit, so it's
not this paper, is it? No.
It is. You scroll down and let's see. It's called plasma petroglyphs, earthworks, and megafauna extinction. It's pretty far down there.
We did a show on it.
Yeah. But I'm going to find the page number, and we're going to talk about it, because we didn't get to, when we did the show, we didn't get to talk about the propagation of the Thunderbolts. I remember that now. We didn't really go into that. So if you go to, looks like page 117.
Hot. I got to find it.
It's hot.
What the date was that you did that one? Could you remember, Ramon? Because they're all dated on the site.
Oh God, we did it. We did that show. We did that show.
How many years ago? How many years ago did you upload the paper?
Oh, the paper is from 2018, I think.
That's
Maybe
probably when we did it.
No, it was. I think we did it in 2019. I think we did the paper.
Yeah, but that sounds about right. You got so many papers.
Yeah, I know. So page 119 it is this, where I start the lightning physics, and this is from the work of Uman, and I'm quoting him here. So the 4 types of strikes. Well, actually, this is my summary.
I like this. I want to talk about this sometime, Ramon.
And then, you bear in mind the problem of lightning, how it's initiated inside thunderclouds, one of the biggest unsolved problems in lightning physics, one of the biggest mysteries in atmospheric physics, etc. So this is very interesting. So you keep going down, then comes the page on On page 120 is the step potential.
I'm still trying to find your paper. I'm still scrolling down.
Oh, really? Okay. Yeah, you can scroll down. Plasma, petroglyphs, earthworks, and the megafauna extinction. It's not the very bottom, but it's towards the bottom.
Right now, I'm at the dangers of warming and replenishing. So, dark matter, songs, the sky, the eclipse glyph. I heard that.
Oh, that's somebody else's. That sounds like somebody else's page.
Yeah, there are other people's
How did I
papers.
get on somebody else?
I don't know. I have no idea.
No, they're all put in there. Yeah.
I was on yours. Okay. Anyways,
You just gave somebody some good advertisement. Free advertisement.
No,
No worries. No, I'm being funny.
But anyways, I recently heard that lunar eclipses slow the rotation of the Earth.
That's interesting. I would have to look at. I haven't seen that, but in some degree, it wouldn't surprise me.
Yeah, that's what I heard. It was in a crop circle, believe it or not, and they deciphered it. And it said that's what it said.
Huh.
Okay. All right. It's called plasma.
Plasma, petroglyphs, earthworks, and megafauna extinction.
Can I just type that in?
Yeah, you just can. Well, you got to scroll enough
I'm not
to where
finding it.
they hide. They hide like older. They hide the older papers, you know. So.
Oh. Okay.
But
Well,
if
I'm
you-
looking at plasma.
You control F. Just find megafauna.
Found it.
There you go. And then go down to page 117 there.
Okay.
117. Well, really 119.
Ooh. Okay. I'm almost
I'm
there.
57, Greg.
I went a little too far. Okay. 113, 114, 15, right about. Ooh, that's cool. I like that. 117. Right. Okay, I'm on 117.
Right. So
Solar,
what I'm
wind,
doing
electric.
is I'm combining the works of several people here. We've got Donald Scott, we've got Jurgens, and we've got Uman. And then we finally get to, on page 120, we get to the step potential, and it starts talking about the step potential. And this is important. The higher the soil resistivity and the current, the higher the step voltage between A and B. The larger the distance between A and B, the larger the voltage between A and B. This is important. If you're a megafauna, you have feet wider apart than other animals. This is absolutely key evidence. So in the model, if you look on page 121, this is his stuff from page 90 of his structured protection grounding text.
Mhm.
It talks about a model, a spherical model. I maintain that people. This is actually from Don Gurnett's work. If people want to take a look at a better model, maybe someone could do the work on a cylindrical mathematical model. I'm no longer I'm not a big fan of doing calculus anymore. So if somebody really intelligent out there wants to do cylindrical, because obviously, you know, the geology of regions like the Midwest is that you have large sections of bedrock that are running as basically big parallel sheets. So this, the lightning model with it going in a sphere is fine, but I'm almost certain that the cylindrical calculations would actually propagate the step potential further from the strike than the spherical model. But that is something I haven't had time to go back and verify myself. So on page 122, it explains how you measure the step potential, and why it's really important. The wider the person's feet are, the more likely for them. And the way it works is this: your body has the same basic resistance. We'll call it an average impedance.
Okay, well, that's the end of part one. Went pretty well, I thought. Had a couple of goof ups, but it was all right. So I just want to come out, say hello, see who's here, say hi. And we got, whoa, Alchemy 88, hello. Tom Bolo, Janice Phillips, hello, Janice. Ray Carr, Janice again, and Ray Carr, NDH. Hey, NDH, what's up? Renegade, Holloway Arts, good to see you, man. I ain't seen you in a while. Nice to see you. And, come on in and have a chat with me in the Great Hall. I love talking about the medicine men, Roy Rush and Garden of the Gods, of course. Beautiful name. James SS, and James. Holloway Arts. It's good to see you both. You too, James. And Shockwave is here. Hey, man, what's up? Read up? What do you mean, read up? What's that? Okay, got a few more here. Unbroken 1010, Learn, Share. Kronos is here. Oh, man. You got to check out his videos. I'll put a link to his channel in the description when I can. It's good stuff. He's a good guy. Ancient History Criticisms, Unbroken, and of course Shockwave. I got a little something that I did with him earlier, and Idusa and Grouch. Ancient History Criticisms. Good to see you. I'm not real good at this, but I have to thank some people that really came through for me. And man, these folks that are I call super supporters, because that's what they are. I mean, they make this channel go, and they give me the inspiration. Of course, all the kind words do too. It's whatever that you can do. If it's a thumbs up, great. If it's a comment, awesome. If you can donate a few bucks, well, these folks have stepped up big time for me, and I just want to give them their props. Don Holden, he's been with me forever, and man, you get a lifetime pass. Andrew Sparkinson, same thing, he's just golden, solid. Green Zone Institute, Mr. Gregory Heffron, I'm solid. Nigel Haig, a new donator that just blew me away today. That's all I can say. Giovanni Martin, thank you so much for your generous donation. Tyler Yaros, Gerald Burbage, Gene Metz, Bass Smouter, Andrew Davies, of course, our friend Grouch, Annette Foley. Grouch is like he's here, given to the show, and given to the show. Awesome guy. Annette Foley, my friend Barbara, Tony Ware, Janice Phillips, solid as solid can be solid. And then there are my Patreon supporters, the few and the mighty. Ross Carlian, Tyler with Stanley, Top Knot, and last but never least, Diamond Dave from the Oppenheimer Ranch Project, who I owe everything to with Patreon, because he was the one who turned me on to it and was my first supporter, and he's still with me. Thank you, Dave. That means a lot. And that's really, I'm not good with this kind of stuff, but I had to say that because, man, it gets me emotional. Thank you. Okay.
I would like
back
to say
the
thank
show.
you, brother.
Oh, you're welcome, man. I love to do this, I really do. And all you folks out there that give me the kind words and inspiration, man, I couldn't do it without you. Really, you guys make the show go. And that's not no bullshit. That's the truth. I mean that. SD Cap, Stephanie, all of you, thank you very much. Okay, we're going to get on to part two. Speaking of Dogstar, I owe him a song because, man, the last video, the last live stream, I wanted to cut out the first two songs because they were a little loud, so I wanted to cut them out so I get right with this stuff. But I cut his song out, and I didn't cut it, but it cut it. So I want to play his tune, and then I'll be on with part 2, if it's okay with you. It's really good. You'll like it.
Oh, yes. So fun to perform, the energy coming back. I believe so.
So then you have V equals IR. If you have the same R, then when V goes up, you're also going to change the current at the same time. Does that make sense? Because R is constant, V goes up, I must go up. If I goes up, then you have a problem for large animals. Well, for anything, really, because it only takes 30 milliamps to stop a heart. But for the larger animals, they're going to have an increased amount of current going through them. And as you know, elephants or mammoths, mastodons, etc., would have had very sensitive feet. This is a known thing about elephants, that they have extremely sensitive feet. That's probably an electrical property. So you have all these animals that are very large, that are not in caves or not in trees. Grizzly cubs can climb trees, and black bears are in trees all the time. But short-faced bear probably could not climb trees. And giant ground sloth, I mean, it's going to be a problem. The camels, the North American camel, the dire wolf, the American lion was a massive creature. Mm-hmm. And all of them having wider footprints, they're going to attract more current.
So
this is the key to the problem. No,
using that
possibly have off the soul, if you get what I mean, Ramon.
Get off the
feet would have like their feet would have a sole that would be sort of more softer. Would be, it's not the right word, but right. it would be more able to feel what's going on around it. Because as they're walking, that would be one of their things that they use to track their environment. So, of course, it would be more open to a change in an electrical current.
So when you go down to the page 123 is when I start getting into the different voltages based on these equations. Mm-hmm. And you see, you can even out to 10,000 meters, you can sustain a very high voltage. I have a minimum, I have a maximum, I have an average, and then I have my limit of what I think is likely. So you're still at 3,000 meters. You're out at 10,000 meters. I mean, these are rather large. So then I step through about the 10 milliamps, 30 milliamps, etc. And quote. So you get down to table 14. And you can see where do you see the milliamps start to drop off, and depending on the way you interpret the potential, the set potential here, we have a 3.5 meter footprint for a Columbian mammoth. The way I'm interpreting it is that at 5,000 meters, you can still kill a mammoth.
That's over 10 feet.
Correct. They were big. But and mastodons were smaller. But when you have something, and this is a single pulse. Remember, the concept here is a single pulse. If you have a continuous pulse, like these Lichtenberg formations in Kentucky, and this maybe the Higgs dome, certainly the Rakat Formation in the Sahara Desert, probably the Devil's Tower and Ayers Rock in Stone Mountain, Georgia.
Now this would be negative electricity, right?
Well, it wouldn't much matter in terms of the heart. That's not gonna make a difference. The current is all that's going to make a difference, because you're going to disrupt the natural current of remember the charge distributive networks of the body. They work on the continuous propagation of a proper signal that comes from chemical ion interactions. And now if you go introducing charges from the environment, those charges have fields, and those fields interrupt the charge distributive network circuits inside the body. And so when you pump the ground, if you have a continuous circuit, you're pumping the ground full of these charges. You're creating an environment that is unhealthy, even if it doesn't kill them immediately from step potential. it's just not a healthy environment for living creatures until that charge dissipates. And again, we do need cylindrical modeling for this. But I think this is pretty good. You know, using these guys, it's solid work from Uman and them. You know, and the Don Garnett for the grounded protection. And you know, we get a pretty good idea that these Thunderbolts, single pulse, could kill at thousands of meters away. Thousands.
You know, they say
about
that
2,000 meters is about a mile.
right. They say that earthing is healthy, you know, because electrons are good
1.6
for it.
kilometers to the mile.
Right. Yeah, and so the Palladian Thunderbolt that's here is 1,840 meters wide. And when Thomas Jefferson asked the Delaware chief what happened to the megafauna at the Big Bone Lick of Kentucky, this is where American vertebrate anthropology or archaeology began. It was in Kentucky. In fact, Thomas Jefferson used to send for mammoth and mastodon bones. They lost an entire boatload into the Ohio River. Huge amounts of bones. Yeah, but this was before Lewis and Clark.
Oh.
He was sending off for these. He was fascinated with what happened to him, and he asked, and this is at the beginning of this paper. If you want to read the quote, I'll make sure there's nothing else here in this that we want to look at the set potential. I mean, you get the point, right? They can go out a lot of ways.
It brings one question to my mind. It might be a dumb question, but if that's true, then if you stand in the yard with your feet wider apart, you'll receive more charge.
That's correct. Well, you'll receive more current because you have the same resistance.
So that would be better.
So lift 1 foot. If your hair starts to go up, just lift 1 foot, because you can't outrun.
SD Pally GRL said, "Thank you, dear." Winky face.
Set potential. So look at page 4 is the Thunderbolt itself. And the quote. Oh yeah, right. The quote with Thomas Jefferson is on page 2, and I'll read it while you show people the Thunderbolt itself.
Okay,
Thomas
and that's
Jefferson,
on 4?
Yeah, that's on 4. So Thomas Jefferson is often referred to as the father of American archaeology. Is fascinated with both mastodons and the Ice Age American. Unlike Franklin, speaking about the Big Bone Lick of Kentucky, Jefferson was convinced that people lived in the Americas at the same time mastodons were living at Big Bone Lick. His reasoning was based in part on the oral tradition of the Delaware Indians, which he had recorded firsthand. During the American Revolution, Jefferson met with a group of Delaware warriors and asked them what happened to the great animal whose bones were found at the Salt Lakes in the Ohio. And the chief in the group stood up and said, "In ancient times, a herd of these tremendous animals came to the Big Bone Licks and began a universal destruction of the bear, deer, elks, buffaloes, and other animals which have been created for the use by the Indians. But the great man above," that's Zeus, "looking down and seeing this, was so enraged that he seized his lightning, descended on the earth, seated himself on a neighboring mountain, on a rock in which his seat and the print of his feet he hurled his thunderbolts among them till the whole were slaughtered, except the big bull, who, presenting his forehead to the shafts, shook them as they fell. But missing one at length, it wounded him in the side. Thereon, springing upon, he bounded over the Ohio, over the Wabash, the Illinois, and finally over the Great Lakes, where he is living at this day." So it's a pretty straightforward story. I mean, it's what I would say is unambiguous what the natives thought about that. And then, I go into the Ojibwa and the Chippewas. This all comes from Graham Hancock's work. And then you have the so-called Battle of the Great Animals from Erdos and Ortiz, 1984. And so we have now the Thunderbolt, the 56 craters in the Octagon. To see the Octagon, just turn your head a little to the left, and then it becomes more obvious, because it looks like a circle, like a bad circle when you're looking straight up and down.
I remember.
Just turn your head left a little, you can see the Octagon.
Yes, you can.
So that thing is huge. Basically a mile across. How much of the ground around it was pumped full of charge, and in all directions, and that's a single pulse. You take the Grand Canyon or something like that. I could see it easily altering the environment. I'm not discounting Andy Hall's theory, though, that there was a big giant storm, a vortex that, sort of like our own Great Red Spot going on. That's completely possible. I think that he has lots of great physical evidence. Lots of physical evidence.
Sputtering plasma.
But you possibly would get a giant storm after that event.
Yeah, according to
Yeah,
Andy,
but
there were
he's talking
charges,
it's like
right?
sustained. He thinks it's a sustained event, and I would say that kind of level of energy is more from the formation era. It's more from the Saturnian era, whereas we're talking about what happened in the last 10 to 12,000 years, and it has to be the right amount of energy. This is one of the key points in my paper. Is that you can't have so much energy that you would basically have killed the whole world, but you also have to have enough energy to be figuring out how are you going to boil or melt away ice sheets on the entire half of the planet, presuming that the ice ages are a real phenomenon. There's some arguments against that, but
Yes, there is.
but let's just go with it and say there is 2 miles of ice in above the Hudson Bay. How do you get rid of that? It's not going to be a comet. Period. It's just not.
No.
Well,
But if you had energy going in there, well, you've got that photo up at the moment with the blue line. If you had energy going in there, that would run down, eventually looking for a point to come back. All right? So and if there was ice above it, it would be getting fairly warm down there.
why did
and
he
it
cut
would
out?
start melting the ice. Are you still there, Ramon?
Yeah, I'm here.
Yeah, you disappeared for
Yeah.
a minute, Grouch. A little bit didn't come out, but most of it did.
I think what he's saying.
Right.
The
Well,
return current.
If you had an energy go through, the current would go through and look for takes the shortest track, doesn't it, Ramon?
Right.
Not necessarily the shortest, the current would least
The most convenient. It's the most convenient. Where the resistivity is the lowest.
And if you had ice, and it would generate, I suppose, heat, and that
of
would melt
least
ice from
resistance.
underneath.
If I may
and-
digress for 1 second, I just want to blurt this out. It looks as though that, from what I say, the lakes all look like they're in some kind of a line. It looks like though maybe some kind of an astronomical body took that course across the Earth and there were discharges, and that's what caused the lakes.
Now, see, that was the argument that I have in the paper. I do want to point out on page 19.
Plasmoid. Page 19.
Yeah, on page 19, I show the difference between, in Kentucky here, 2 known bolide strikes. Very famous Middlesboro crater because there's a city in it, and the Cumberland Gap is there. So that's a historically, and then Jephthah Knob, which is a smaller strike. Both of them oblique. And then comparing them with this Thunderbolt, where you can see that there is no major bow shock and there is no oblique strike. This is very clear evidence. And then I step through and I go from there. So you get to the Hudson Bay craters on page 22, and you compare that with the Chicxulub crater. The Chicxulub crater has the bow shock. It has the lower central raised period, but the Hudson Bays, the elevation's higher in the center. So I cannot see how these could be the results of comets. Okay, the Chicxulub crater is clearly something physically landed there. You can see the blasting out.
Been boiling there.
Well, isn't that atypical of a lightning strike in the middle?
I couldn't understand both of you guys.
I know. I'm sorry. Go ahead.
Okay. Sorry. Has that actually been boiling there? Like molten? Like really, really
It looks
hot?
like something was melted and it dried, or it cooled. But this looks like lightning strikes or thunderbolt strikes because it often has a mound in the middle.
Yes, and that's the important stuff from Yelverson's work. I forget. There's more tables here, and I go over the different. I think we'll skip the next table. There is some cool stuff in there. There was something that you had brought up in it. Oh yes, the pathways, right?
Yes.
Somewhere in here, I do describe the moon's pathways, the way how it meanders. There's more legends. Oh, the Lichtenbergs of the knobs are on page 81. If you want to see them.
81. Okay.
Yep. Yeah, and these are the places where the knobs are the strongest in their Lichtenberg formations, and they're not just
I'm going to have to go through this. This looks really cool. I did once before. That's why I noticed that comment that everybody thinks is a snake. Yeah. Oh yeah, Lichtenberg. Yes.
Yeah, you can see how it's flat, and then the Lichtenbergs are just going out from that point. You can see what's fluvial. The normal fluvial, but to call this upthrust is absolutely ridiculous. There's nothing upthrust about. These are Lichtenbergs. But then they're all at 900 feet. And then I go through some of Andy Hall's stuff. Talk about Barringer Crater and the Octagons again. Go back to the Octagons. Talk everything about the Octagons. Various hinges and stuff. This was an early work that I had done, so it's got a lot of stuff. I had to put a lot of things in. And now, everything can be a little bit more spread out because there's plenty of work. Oh, yeah. So page 110 is where I start proposing. Well, 109 is where I had calculated how many. Well, I guess it's actually 108. I'm calculating how many Vadras it would actually take at full distance, half distance, third distance, quarter distance of the moon to where it is now. To actually, boil Antarctica, and you can see it's actually not that many. The further the distance, if you're able to create an arc, you get some pretty powerful Vadra. I have the energy in kilocalories. And how many lightning bolts, roughly, we're talking about, the equivalent of regular lightning bolts. I mean, these things were massive. Of course, this is an arc, not a Paradian. Okay, this is important to remember. This is literal arc connection. So you get down to, on page 110 here, I'm proposing an idea of like how this would have actually happened, where the moon comes in closer, approaches, and you have a massive spike in the electric field, and then goes out, and now you have a scorched moon face, and it comes in, and now it begins finding, and then it gets closer again, then it goes out to orbit. So exactly this kind of idea of a passing over is exactly what I'm proposing in this paper. The moon was the most convenient vector that I had at the time, because I didn't have a star exploding above us, right? This was presuming the same star that we have now, back when I wrote this paper. But now we can look at it and say, well, there might have been multiple things that came along and scarred the Earth, because everything has got different scale. The Grand Canyon is of a different scale than Ayers Rock, and of the Paradian Thunderbolt here called Big Sink, and the lake, the Great Lakes of North America. They're all different scales. So if you have different scales, the most thing I immediately think of is different potential power levels, and that could be created by changing distances or the physical actual size, because there was a time that we were briefly near to Neptune. And how that happened is that we were going around Shamash. Shamash then splits. We're still going around both. And then Shamash, Proto-Saturn, outgasses and forms Neptune, and now we're going around 3. And they're getting further and further apart, and we're at first pulled in towards proto-Saturn, but at some point we have a touch with Neptune, and I think that's about the time, based on the Ramayana's description of this giant blue monster with one eye and no head, that was about the time mankind started heading for the hills, so to speak, going underground and getting into underneath the dolmens, and ceasing any kind of agriculture. And then from there, and then after that we were nabbed by Jupiter, and all that's the new paper, which will come out. I'll have it out sometime this year.
Seeing that that's the moon, and it would probably maybe have been the last thing to come close to the Earth. I would think the people would have saw it coming and known to take cover by then.
But they did. It's in the anomalies. It's in the anomalies. The Watcher moon is installed. Marduk himself comes and he smashes Tiamat's head, breaks her lover in half, and smashes Tiamat's head, and then installs the moon as a watcher over the corpse. So yes. It was bad days, bad days.
Yes, indeed.
I'm trying to remember. So it might be in the moon, the M plates. I've got some really good examples.
What timeline would you be looking at there, Ramon?
What now?
What sort of timeline? What sort of timeline?
Well, when I wrote this,
how long ago would that have happened?
Yeah,
Dogstar said it's a party.
The Clash of the Titans appears to be between 7,000 and 9,000 years ago, and then the Marduk taking over about 7,000 years ago, and then who knows how long exactly the reign of Zeus would have lasted, but I think it could not be any more recent than
Athens said, "Is this a video event?" I'm not hearing anyone.
Probably more like 5,500 years ago, and then you have Venus and Mars, and I think that Velikovsky starts to become correct about that time. That
Did somebody say they couldn't hear? Is the sound okay? Oh, shit. I gotta get to you.
Oh, it's coming
Athens
through
said,
excellent.
"Oh, okay. Like people just joined and it started with one."
Somebody said they couldn't hear, and I got a nightmare. Okay.
Yeah,
Well, I guess it's
okay.
all okay then. All right.
Yeah, the stream's going good here on my end.
All right. We'll get back to it. I'm sorry. I just wanted to make sure that, everything was everything. All right. Back to the show. Oh, where are you? There you are.
I think it's reasonable to say 3,400 years ago to 4,400 years ago was the Venus event, and Mars-Venus interchange, and then that the Mars coming near to the Earth was probably 800 to 1,000 years ago, and kicked off the age of the warring states in China and wars all around the world, the end of the gods. I think that's all correct. The Neptune, I think, is probably between the Tepe period and the megalithic period. I think it is the defining characteristic of the archaic period. Why we could not perform above ground real agriculture. Why we had to grow trees and then go hide in the caves, and then come out and pick the trees, then go back into the caves. In Kentucky, there's lots of caves, so that was not too hard for people to do. Cherokee known as the people of the caves.
What do you think is the reason that we have caves? What caused them?
Well, I don't know if the Kentucky caves. Of course, the Kentucky caves are the longest in the world. They've plenty of signs of fluvial activity. There's not a lot of formations. There's a few. The ones that have formations are knobs, and they're probably created electrically. But most of the caves are basically long river tubes. There's a lot of water in Kentucky, and we have the most waterways outside of, say, like Alaska, because that's such a large place. But here, they're historically important. These waterways are really, really incredibly important. So, was there transmutation in these caves? Maybe. But I'd say that they were actually pretty safe places because people were living. We have mummies. We have Kentucky mummies, and they were buried in the cave. That's a whole conspiracy by itself. There's a lot of archaeological conspiracy theories in Kentucky. We actually know more about the Mayans and the Aztecs at this point than we know about the people that were here. Probably because of the wars and maybe because of the cataclysms. Certainly something interesting happened also, at the Great Serpent Mound. And all of that leads to more mystery for the entire region.
Because when you have a point like that diagram that Greg's got up, of course, you'd also be getting a lot of earthquakes.
Which page? I can't see.
That one is up there now with the moon going close to the Earth, page 110.
Oh, yeah.
The author's idea of Earth-Moon intercept path, right? When you had those sort of occurrences, you would be also getting a lot of earthquakes, possibly, and even volcanoes.
Yep, and mega tsunamis. Yeah, it would not be a pleasant. This, of course, is not to scale. This is just a concept of how. But when we look at how the moon moves, even still, like I mentioned with the, when we look at the predicted pathways for the next 50 years worth of eclipses, there's nothing regular about the pattern. This is a belief people have in their head, but there's just nothing showing that kind of actual repetitious behavior. The computers help us to model that, and so we have a really good grasp on when the eclipses are going to happen. But for a long time in ancient history, they really didn't know. And you could at one point in China, if you didn't predict it, you're an astronomer and didn't predict the eclipse, you would lose your life because it was considered absolutely vital information to know. Survival, of the empire or of the kingdom, sort of information to know.
Mm-hmm. I just got shown something by my son. He just said that he didn't know I was going to show, but I muted it, and he said he shows me something that just came up, and it says powerful jet emerges from a black hole. Now we got to know that if it's so great that not even light can escape, how can a powerful jet? This is it right here.
Yes. That's what I was
referring to. Plasma.
Right.
It's got to be a plasmoid. Yes.
It is, and they're peeing on us without calling it rain. Mm-hmm. It's really an embarrassment that we're getting to this stage of lies. But what can you do? It's the arrow, and I guess you would say
you can't deny physical proof right there that if not even light can escape and it's belching a plasma jet, it's not a black hole.
Right. Period. There you go. End of game. Checkmate.
Yep. But they still stay obtuse.
Andy Hall's. I just want to, before we close out that paper, Andy Hall's arc blasted images.
Yes.
That's page 152. You can see 152, and 153. Those are some layered depositions. Again, those are waveforms. So I think he has really great, solid evidence that there was this giant storm and large electric connections. It's just that if you have energy of that scale, okay, that is going to wipe out not only megafauna, it's going to wipe out everything. Mm-hmm. I mean, this is going to the amount of electricity and the heat and the winds And that is just not what we have for the Younger Dryas. I am certain that it happened in a more Genesis sort of formation period of the Earth, and so that's why it's important to me that we differentiate between what Andy Hall's looking at, what I'm looking at, and then what like the Salt Dome and different people are looking at. There's just different. It's all about the scale, and here's another point. Okay, so we're talking about the jets coming out of the so-called black holes. The current level for those is between 10 to the 16 and 10 to the 18 amps, depending on the level of active galactic nuclei that you're studying. Okay, but now we know that these galaxies are going in concentric tubes. They're going in these circles, moving across the intergalactic space in these clusters. So now, if you have an entire galaxy, which can be calculated a certain amount of charge, presuming the stars and their values on average, we could look at the light output, and now they're moving in a circle, which is going to create a magnetic. You're having an induction here, because you're moving material that's charged in a circular manner. You can calculate the kind of current that's going between. That's going to exceed what we thought was the greatest current. The flux won't be very high, but the total current will be, it'll be astronomical, for lack of a better term. The numbers for that kind of current are not really understandable to the human mind. We're not very good at going beyond 100 billion. So now when you get out to 10 to the 18 amps, it already seems completely ridiculous. And now that's probably going to approach, I don't know, I'll guess 10 to the 50 amps. And that's a simple filament. There's probably filaments that are in a super excited state. I think that there's that one filament, it's like 2,000 light years long or something like that. Somebody,
yes.
Don't quote me, but it's a long filament. It's like the longest one.
Oh, there's one that's 15 parsecs.
There you go. Okay. The kind of current that's going through there is so astronomical that it defies, and I think that's the problem for the astrophysicists. They can't wrap their heads around that. So now when you come down to geologists and archaeologists, when they're looking at these different scales of energy, they're going to have the same problem as the astrophysicists do with the current. Okay? They're not going to understand that the scales change the behavior of the force and change the way that force acts upon matter. So unlocking the secrets of instant petrification, or of puttification of crystals, or of cavitation, are all going to be scale dependent. And it's going to create pockets of study of the force. And that's going to lead us down various rabbit holes that keep us from seeing a central fact and truth. It's not that just I'm a syncretist the charge is there. I'm definitely a syncretist. I deal in philosophy, I deal in medicine, all these things, I bring them together. And the attempt is to bring them together under a cosmology that works. First of all, the plasma electromagnetic cosmology, which is an open source cosmology. I don't own any copyright to that. Anybody can write plasma electromagnetic cosmology papers. And then under the EPMC, where now we're extending it and we're saying, hey, how can we stretch this cosmology? Because if it's a real cosmology, it should be able to explain lots of things. The fault of older cosmologies is, it's fine to say that the Earth is on the back of three elephants who are standing on top of a tortoise until you go and you look. Okay? But you can explain certain things. You got earthquakes here, you got gods, you got things that you need when you're telling children around a campfire. And that's what a cosmology should do. As you expand your awareness of what that cosmology needs to be capable of doing, that's where you get the real test. And Big Bang just can't do it, which is why I have a whole paper called, it's an opinion paper, I label it as such, but that Big Bang is not a real cosmology. And it just does not help us to define anything, human nature, human law, human ethics. Why are we behaving the way we are? In Gareth's new video, they were in the comments talking about, where does consciousness come from? Right. Our cosmology needs to talk about that. It needs to actually go beyond, because all I've done is talk about the charge distributed networks, and now I'm writing about IQ assets, but that's more of a strategy paper. It's not really an EPMC paper, technically. But, you know, when you talk about these things, but where is it actually coming from? Where's the consciousness coming from? We need to be able to make predictions and get ahead of the theorists, because the theorists come up with really interesting ideas, such as the theory of mind. The theory of mind is, you know, that complexity creates an emergent property, and that emergent property leads to consciousness. And then this informs the possibility of the Gaia hypothesis, for example, that the complexity of, you know, say the crystals of the planet, or the biosphere of the planet, the microbes of the planet, the root systems of the planet, that all these come together and they create this Gaia effect. And guess what? That does pass enough of a sniff test to become a Harvard paper, and certainly to influence a movie like Avatar. But it doesn't answer the fundamental question, which is how. How does the plasma electromagnetic force create that emergent property? Well, we have lots of ways to go. You know, we have discussions of electrobiology are really kind of gaining steam. Grouch, you go Grouch I or Groucho, or just Grouch?
Grouch.
Just Grouch. Well, Grouch. He mentioned it earlier, that the sensitivity of some of these animals. But there's the spiders. A lot of people don't know this, but we now know the spider webs. They're not just like sticking webs out in the wind is going. When they get on these spider webs, they are following electric fields across your street. It's not like some special wind came up and they said, this is my time now to fly 40 feet across the road. They don't. That's not how they work. They're sensing an electric field, and then they are setting out their line, and they are catching charges, and then using those charges to float. They are levitating across the road. It is not a special wind that is coming along and carrying them across the road, just them and no one else. The spider is laying an antenna, and it is knowing how to do this. And birds are riding these thermals. How are they finding these thermals? They don't have IR goggles on. They're finding electric currents and electric fields. And this is the time for mankind to get this, because if we don't get it, we're going to end up in World War and set ourselves back another 10,000 years.
Absolutely.
And they won't even find us. They'll still find the remains of the Great Pyramid, but they won't even find, you know, New York City by the time they figure this out. So it's really vital that the right cosmology actually win. And it's not just vital for our survival here, but for the accomplishment of our so-called destiny. If, you know, in the Chinese concept of destiny, by the way, you don't always reach your destiny. In fact, frequently, fate robs you of your destiny. Like Bruce Lee, like fate robbed him of his destiny. Mm-hmm. You know, there was destiny left in his data stream. So, you know, the world was quite sad when he died young. So it's not a given that mankind will terraform Mars and Neptune Venus, and take water from Europa and you know, and seed the entire rest of the solar system, and then from there build up our star fleet and go out into the stars. That is not some kind of promise, any more than it's a promise for the Asiatic lion to, you know, survive and conquer all of Asia again. It has, you know, shrunk down.
We may even lay the groundwork for whatever comes next.
Well, I hope so. I absolutely hope so.
Be the case.
Realistically, if we just, you know, say, yeah, you might not achieve it, we might not achieve. So if we haven't been total selfish, we've left the groundwork for the next whatever. You know, you could put that into modern life. You know, you try and leave something better than what you were given.
Well, that's a good point. But there was a time in between whenever the Egyptian scientists were really, truly figuring it out and creating electric fields and using Crookes tubes in order to light their way through tombs. And then the Dark Ages. I mean, we've got to think a little bit more forward, because if we approach things the same old way and just kind of wait and see, I wonder if we will quite get it, in time. But regardless, now is the time for us to make a strong push against lying narratives, whether they're pseudosciences that I guess attract young minds who are skeptical minds. It's reasonable for them to be skeptical. They've been lied to for the last 30, 40 years, right? Greg, you just mentioned the black hole thing, right? They're lying outright, And so when people hear those lies, their soul registers that, and then they go and they look, and they end up being flat earthers or something. And so now's the time to push back against that, because the electro-geology is coming into place. The electrobiology is coming into place. The astronomers are proving a lot of things for us, which is nice, because then the heavy lifting is done by them. They are trying to steal credit too, but they're going to do most of the heavy lifting for us. And then you get to the mythology and the cross mythology. There's going to be a lot of hard work there. And if this stuff can come together into a more cohesive manner, then we might be capable of actually getting people hooked back into the juice again. And when we got them hooked into the juice last time, we had industrialization and the world changed. I mean, it truly fundamentally changed. I was talking, so one of my new papers is the MEMS, the membranous interface of the material and spiritual. So it's a philosophy paper. And I was talking with my student about it. And, Thomas Edison, he tried over 700 times to get the light bulb working. He really, really, really wanted it to work. If you went back in the old days and, to the days of the Bible, and they say, okay, asking ye shall receive. After 20, 30 times, everybody would be saying to him, God does not want you to do it. In fact, it may be actually a work of the devil, or, you maybe shouldn't do it. It's illegal. Maybe we should burn you at the stake. Okay? He had to go through 700 trials to get this thing to work, and then it changed the world. This interface of the material and spiritual is of vital importance for technological and innovation and design. And we really don't understand how it works. We take for granted loads of things. In the paper, I go over a grocery store visit, and my student looked at me like, well, why is that a big deal? And I'm sitting there going, are you kidding? This is a really huge deal, because here you have a building full of millions of calories, and nobody is looting and burning it and running out the door. In fact, they're holding off their desire. They're handing over this hard-earned money. The person who's taking the money is not pocketing or stealing the money. They're putting it in the register to give it to the owners of the business. And there's a peaceful interchange, intersection of energy here. So the material and the spiritual, in this case, spiritual meaning, psychologically related, are meeting together and they're interfacing. We can design better systems based around this. And the electric force is related to that. And the other example I give in the paper is crypto mining. Crypto mining is an emergent property from the post-mortgage crash. And it is literally turning the use of electrical energy into money. When you get down to the fundamentals, there's a lot of math involved in technology. But that's fundamentally what's happening. If that's the kind of direction we can go in, I predict good things for mankind, even if we have to burn some oil on the way. Mm-hmm. But the more that we invest in pure magical thinking, this is not going to work. And I have nothing against Harry Potter movies or anything like that. I find them a lot of fun. But I'm more interested in, when somebody goes, hey, how do I make a real lightsaber and then they turn to plasma, like the hacksmith guy.
Yeah.
That's the kind of stuff I like to see.
I recently heard they spent like billions of dollars in France, I think, trying to make a fusion reactor work, and they still haven't been able to do it.
Well, they're probably not
No,
using
that's still being built, Greg. That's still being built. That's still being built.
Oh, okay, so they haven't. Okay. They got sapphire.
From memory, from memory, it's around $11 billion to build.
Mm-hmm. Yes.
And there's heaps of different countries involved in it. Mm-hmm. And I did see once where they're talking how much power they're going to use, and it takes something like 2 or 3 years to get it to the point where it should be working.
Looks like a man running. Well, yes, but up until today, they have not been able to make fusion work, and they're not going to. I don't believe fusion is...
And they're not
without pouring more energy into it than they're going to get out of it. But then you got sapphire, which is getting more energy than it's putting in, and they ignore it.
Well, it'll be a form of fusion. It'll be transmutation. Really, it's what it is.
Isn't it more like fission?
It'll be a form of with transmutation you have it's basically a small version of what's happening on the big scale, which is cosmic rearrangement. And the way cosmic rearrangement, I have to write the paper on that still. The way that cosmic rearrangement works is you have first of all, there's no beginning. Everything's always been moving around. But so let's just say that you start with starting point A. Starting point A is a vector. So you have an origin point and you have a direction. As it moves along this direction, it induces a magnetic field, right? It creates this change in this magnetic field. When you do that, that is going to induce an electric current in the material objects, let's call them B and C. Now B and C are going to be instigated to move in order to rebalance the entire charge relationship in the fields that have been assigned between these now 3 objects. Well, when they move, that's going to affect the magnetic field, and it's going to create a new structure, a new normal. Mm-hmm. And this is just going to continuously go. And there will be, of course, a breakdown of the entropy over time, but I have an answer for that too. And maybe after I eventually write that paper, we could do the cosmic rearrangement. But transmutation, the way I'm seeing it, is you're supplying energy into the molecule, and it is essentially just rearranging itself to create the best low energy or homeostatic conditions to maintain that element for the length of time in which it can keep. Of course, all these things have half-life. Even steel has half-life. And eventually energy is lost and it changes its form. So I think that we will find fusion, but the fusion will be based on 2 things. 1, this cosmic rearrangement or transmutation principle, and 2, the spongy counter space. And the spongy counter space is where the source of the energy is coming from, ultimately. Some people have called it the void or 0 point energy. But the counter space is probably where all this stuff is being stored. But that's a long discussion there. I'm running out of gas here. It's 1:20 a.m.
Yes, it's been awesome.
I got to work.
A really good discussion, Ramon. I understand. We could let you go.
We haven't done that. We haven't done bad, Greg. See, from chaos, there always comes organisation.
Yes, I'm so sorry that for the last mishaps. I set my alarm and everything, but I couldn't do anything about it. I just, it's just one of them things. But I'm glad it worked out. Absolutely, yes. Have you heard of deuterium or deuterium?
Deuterium?
Yes, deuterium.
Yeah.
Yeah, I was listening to a program a while back that was talking about that might be the best candidate for fusion.
It might be. I would say there's not a best candidate, but a series of harmonic candidates. It's sort of like carbon and silicon, you know.
Yes.
The universe runs off of these repetitions of things, and the repetition, of course, each repetition looks different, but it is also similar. You know, whatever it is about copper and silver and gold and platinum, you know, it's a repetition of a theme, and it attracts us, but they are different. So each time there's it's almost like there's an improvement of value for each one. And if we can get that, there's a few what are currently between science and metascience or metaphysics, things that if mankind seriously invested in, you know, like fusion research kind of money or bigger, would yield dividends that literally take us to the stars. And one, of course, is the changes themselves, which we do study the changes, but we always name it, you know, like, oh, we want to study what happens in the stock market, or we want to predict the weather, you know, or we want to do, you know, how does fluid dynamics work? And nobody wants to specifically study the changes, which is hilarious because it's a 3,000-year-old discussion that has basically not yet been had. You know, operations research is happening, and we're getting towards the discussion of nonlinear dynamics. That one's going to yield huge benefits. Transmutation is going to yield obviously huge benefits. I mean, who doesn't want to literally turn lead into gold? That would be huge. Space energy is a huge area. It's not even really that metaphysical. It's a literal possibility for us to do. And there's this whole series of things like that if we again choose a cosmology that is rooted in the objective fact of lab or space demonstration, you know, something we can find. We could find it in the rock, we could find it in the planetary Tarella, we could find it at the International Space Station, or we could find it on Mars, and it gives us repetitious results. We can build things. So in my MEMS paper, I don't just talk about the grocery stores and the crypto mining, but I introduce the concept of, you know, double layer economics. Why? Because the world needs a new form of economics. Why not use plasma as a base? And there's probably tons of things like that, tons of things, and these constant harmonic repetition and understanding.
It always becomes the argument in our world, the age-old argument between the old money and the young, and I suppose you call it the young money. Who's going to control it?
Right.
You get what I mean?
Yeah, that is absolutely true.
And that's what we're watching at the moment. And that is what we're watching at the moment with so many things.
You know, Tesla's solution to that, though, was to actually give the United States the idea for the atomic bomb. You know, he predicted the entire 20th century in his autobiography, in about 2 pages of his autobiography. And he chose the United States to give this to because he wanted to create something that would dissuade world war. And you know, and that's very smart. I think that yes, who controls the first Palladian Thunderbolt generator will be a big deal. But eventually, we will need Palladian Thunderbolt generators, not for war, because, you know, we'll probably at some point get sick of vaporizing cities. They'll want to use it when they figure it out, which China will probably be the first ones to create one at this rate. When they figure it out, I'm sure that they'll want to vaporize a city. You know, they'll want to pull a Sodom and Gomorrah. But after that,
let everyone know how much power they've got.
Yeah. Yes. The potential after that, though, for terraforming Mars, terraforming Venus, would be too obvious. But I don't know if that's going to be 500 years or 5,000 years. I couldn't really tell you.
Yeah. The stupor that we were in to use nuclear weapons in the late 50s and 60s is just crazy.
It is crazy.
And there was one Irishman standing in their way, thank God. But LeMay and Lemnitzer and all those generals, they wanted to use the bomb. They wanted to bomb everything red.
Everything.
Yeah.
The amount of money, and I have it in one of my earlier papers, the End of the World Media paper. If you treat the whole world as families of 4, and look at the average food, I think it was like 86 years worth of food has been spent on just the U.S. nuclear program, and that's some Velikovsky level, obsession of us. That's a lot of calories. That's a lot of wasted. That's inflation. So, but we can. Fiat money violates thermodynamics, but we can switch from that back to something based on the force. I think that's why they're threatened by crypto. Crypto is volatile right now, and it's not convenient to use. But it is that next stage of a proper MEMS. Cash money was a great MEMS as well. And every time we engineer,
like a young star.
What'd you say?
Could taste like a young star. It could taste like a young star. It's shooting bits everywhere, trying to find its formation.
That's true. That's true.
Where it's like a young person just starting out in their sort of first real job, and it's sort of running around everywhere, trying to be accepted or known and all that. And that's what crypto is at the moment.
Yeah, it's so expensive.
It's like a young infant.
Well, no, cryptos are expensive. Most of them are cheap.
Oh,
really? Because when I looked at it, they were unbelievably high.
It just depends on
the one. The tax departments have got right into them.
Well, then it's something like stocks.
Governments mightn't believe them.
No, they're not. They're not stocks. It's very important that people stop associating it with stocks, because there's a huge difference between them. And on the number one hand, crypto being a new MEMS, it's very important that people understand that it is just another interface between the material and spiritual. If they're able to do that, then they'll put it in the proper perspective. We have lots of everyday MEMS that we deal with, and enables us to manifest what we want into this material existence. And this is just another form. But my main
MEMS is
the membranous interface, the material and spiritual. The main point here, though, is it's at least based on the force. That is the difference between it and, say, cash. Now, gold was also based on the force, because, as we talked about earlier, people saw the transmutation of something. We're speculating, but historically, they saw metal turned into this gold, and then this gold was perfectly conductive and didn't corrode, and they thought, oh wow, this is symbolic, and oh, the star is also yellow. So they're seeing this correlation between those two things. That gives it reality. That gives it something tangible that builds the human up and builds humanity up. And when we are reattached to that, we'll have another great enlightenment. We'll only prolong the enlightenment the longer that we are obsessed with magical, dark universe, nonsense.
Yeah. It's
an old
frustrating.
saying, Ramon, there's no free lunches.
That's right. There are no free lunches. But
Well,
right now,
can
the
you
world
lose
is
money on crypto?
Yeah, of course you can lose money on crypto.
Well, then how is it different than a stock? It seems to me that this is what I think. Those robber barons pretty much ruin the world. And this just might be another kind of thing for them to have people put money in, so then one day, the market crashed, and everybody
Well, it
lost
already-
their money while someone skips away with
It's already crashed, but it wasn't a single individual. In this case, it was China deciding to rain on everyone's parade. But the thing is, Greg, it's a mathematical instrument, and it has a lot of different utilities and a lot of different uses. And the main point is it's a MEMS. Right now, it's not convenient enough to use for everyday buying a pizza or something like that. But they're going to make it the standard anyways. It's coming. So something to learn about anyhow, even if you don't love it.
You think cash will go out?
That's right.
That seems to be their intention, yes.
Mhm.
Seems to be their intention.
I've heard this for
But
many
that
decades.
blockchain, but the blockchain, Ramon, can be used for so many things, and that will be where the potential value will come from it. In the future, the value won't be in trading a current crypto, calling it a currency. It will be what you can do with the blockchain.
That's right. It'll be emails, it'll be
and what you can store on it,
You know,
and
you know-
all that. Yeah.
Back in the 80s, I remember distinctly, there was this thing going around where it said that cash is going to be obsolete and everyone's going to have a computer barcode with a number on their arm that can
Yeah.
be scanned. Do you remember that?
it's still a plan. Cold Fusion has an entire video he did it on digital currencies, the history of digital currencies. The difference is, though, that digital currency was a MEMS when it was created, but the problem is it didn't have a problem to solve, and the emergent property for Bitcoin came from the 2008 mortgage meltdown, and then from then
Ethereum.
it engineered it.
Yeah.
Yes. This is a discussion on its own, isn't it, Ramon?
What did you say?
You get what I mean? This is a whole discussion on its own.
Oh yeah, the MEMS is a huge. That's why I wrote a separate paper. Came out of me listening to the Atlas Shrugged audiobook and thinking about the importance of when you do work. The satisfaction of doing that work, the fairness of being paid properly for that work, and what it does to your soul and your spirit if you're not valued for that. Which indicates, if that is there, it indicates that we may be a little too anti-materialistic. We may be a little too apt to go, oh, it's not the destination, man, it's the journey. Well, no, frick, it's the both. Okay, you need the destination and the journey, and we've become so soft about our approach that we're forgetting how important it was for humanity to lay rail and have a railroad that could go from the Atlantic into the Pacific Ocean. The magic of that, or getting to the moon, the magic of engineering a machine that had such raw power that it could get you to the moon. If people are listening, and if they haven't in any recent time, go out and stand next to a diesel train as it rushes by you. There is something magical about that experience. I'm not saying that I get the same feeling as I do when I go to waterfalls or to Indian mounds, but it is an important experience, and mankind worked very hard to get to this place. Rolling this, doing like Sisyphus and rolling this this boulder uphill. And for us to abandon it in a moment of, I hate materialism, I hate capitalism. You don't really hate capitalism because you're using a phone and drinking Starbucks and, eating McDonald's, okay?
Right, yeah.
What you hate is the soullessness of a society that is disconnected from the PEM. If the society, it's ironic because we're using the force right now to talk and record and do this show, and that's all we're talking
Can't
about.
live without it.
Yeah, but yet these people aren't connected to it. They don't, they used to, you used to be able to go to an electronics store and buy all these parts and build your own computers and all this stuff. And you look at Star Wars, you look at like science fiction of the 60s, the 70s, the 80s.
it was presumed that everybody was going to be more and more electronically inclined. You can watch Keanu Reeves and Johnny Mnemonic, and he's like putting together this hacker suite and he's putting all these pieces together. And I told my son, I said, man, I wish that's what we had turned out to be, the internet. I wish that's how it turned out to work. Instead, it's gone all software.
The internet got wrecked when they commercialized it.
Well, it was
the internet got wrecked. Got ruined the way it was commercialized. If you could get what I mean by that, is you Google search something now, the first page of it's just all ads. And then you got to keep, right, when it first came out, you Google search something, usually very quickly you could find something along the lines you were looking for. That's what I meant by the commercialization of the internet has allowed it to become concentrated power to a couple.
So this is going back to, again, the whole point of the MEMS. When Google was an early MEMS, it provided a tangible value. And what you're saying is it's now not providing that tangible value. It's providing a tangible anti-value. It's sucking value from you, is what you're trying to point out. Is it's no longer performing the role of a MEMS. It's now performing the role of an anti-MEMS. It's a MEMS for someone. It's a MEMS for the Google Alphabet Corporation or whatever. And it's able to suck, material from everyone through ad revenues, et and is it giving back in exchange? Because in an ideal MEMS situation, there would be a dual exchange, or even a quad level, like dual level two level plasma. The dual layers of plasma is really four things going on. So that's where we really want to get to. But at least two ways would be good, because then the two ways would stabilize the material and spiritual aspect of that, so that your mind is not hampered. And you're probably right. But how do we calculate? Because we can't just new age it. We've got to.
It will evolve.
What's involved?
It will continue to. It will continue to evolve.
Oh, it'll continue.
And if it evolves, and like other things will come along. So if it doesn't, if people get sick of it, they'll find other things.
That's true. Something a better product. No, you're right about that.
And my friend and I were talking a while back and watching this video, and it was, did man go to the moon or not? And then this bloke come up with, there was only a 1% chance. And I said to Greg, someone said to me when I was young, hey, 1% chance, Andrew, that you'll get back, but you go to the moon if you want. I'd go, no worries, where do I hop on? All right. You understand what I meant by that?
Yeah.
And it was the same when they did their roads and all that, like Greg says to me, don't you worry that you fall off the tracks? No.
No, I mean, you got to do it.
Engineers aren't bad.
You got to do it.
Engineers aren't bad, are they? Yeah.
I'd just be worried, man. If something just little fault is there, you're going off the tracks, man. And
but if you live that way, you can build society. If you don't have the man walking on the beam at 800 feet above or however tall the Empire State Building is, then you don't have the Empire State Building, which means then you also don't have the Sears Tower and the Burj Khalifa and all the Taipei, and then if you don't have those, you don't have the mega structures that can house 10,000 people. And if you don't have those, you don't have the dome cities on Mars or the moon bases. And it all built upon.
Because people need to take chances.
And if the man starts walking on the beam young enough, he knows no different.
That's true.
Yeah.
Right, Ramon, I couldn't get up and walk on a beam today, but I could when I was 17.
Well, that great Walinda guy fell off a high-rise tightrope in his 70s, so met his end, just going a bridge too far.
Well, he knew what he was, he knew what he was getting into. But his point is exactly correct. If we want people to get into the PEMS, this is no joke. I like talking to you guys, but I think that we're all probably past our prime. Mm-hmm. Okay.
it's the young people that got to be
right.
PEM.
That's right. That's right.
And they've got to be explained to why the Big Bang is nonsense, and they've got to be, and it's got to be patient, you know, and because they're going to regurgitate whatever they've been told, and now they're going to get it even worse than us, because you know we grew up on like Discovery Channel and Carl Sagan and that kind of stuff, right? And Bill Nye the Science Guy. Okay, they were peddling nonsense because they didn't know any better. It was nonsense for them too, and it had been nonsense for the last 70 years. Okay, but this young generation, they're getting Android and Apple feeds of just the worst sort of schlock that has nothing to do with science. I mean,
and they catch on so fast too.
Yeah, and so they're going to believe it, and then they're going to decide that, oh, that's how that really works. There's water on comets, and you know the sun is a fusion, and black holes spew out this nonsense, and we will have to patiently explain why that isn't so, and why it's important, because it is actually important how the electronic works. You know, it's not just, you know, right now they're only worried about, was it going to give me cancer? You know, it's going to give me, you know, corona or whatever. And they're getting back to magical thinking. I had several alt-stream people. They were like, this COVID's caused by 5G. COVID's caused by 5G. So I went and I looked, and it's not caused by 5G. And it was easy to prove. But, you know, it was such an easy narrative for these people to believe because they were already skeptical of the mainstream. And I get it. You're skeptical of the mainstream. But there is a scientific process. You have to put a hypothesis. You have to test the hypothesis. Okay? If you don't do that, that's not science. You know, that's just magical thinking. You know, and this is a common problem. And, you know, you can't build a society that way. You know, because then all you have are people who are skeptical that railroads even exist. I mean, we're going to get to that point. Okay, people are going to say that railroads are, you know, don't exist. So the mind trickery that's happening is getting to a level of mental gymnastics that's unbelievable. And pretty soon people will start demanding that we destroy the modern world in order to return to a tribalistic life. And
that's what's happening now.
It is happening now. But it's happening from like more of a communist socialist level. I'm talking about full on, you know, commune style, even worse than commune, like all the way back, you know. And then you know the irony is they won't want to rip out hearts to Venus. They'll be ripping out hearts to Wonder Woman. And they won't know that Wonder Woman is Diana and Diana is Venus.
The thing I noticed about today's system is when you're talking about, you know, well, let's go back into the commune. Yeah, that's all right. But it seems to be there's a lot of them that want to be part of the commune, but they don't really want to do any of the work involved. They've got to make sure they've got a heap to do all the work for them. And that's the big problem I see on that side of it. Is if you're going to be part of a commune, that's well and good, but you've got to realise if you want to be Fellow Diamond doing his permaculture and that down there, if anyone measured the hours of a day that he's using growing his own food and doing all that to be independent, he spends a lot of time doing it.
Exactly.
Right? And you'd understand what I mean, Ramon?
Yeah, exactly.
Anyway,
No, I completely
suppose that you tell us back there.
I'd like to get back to electromagnetics if we could, because we're kind of digressing here.
Well, we're not completely digressing. Remember, extended plasma cosmology. The point is that if people are connected to the PEM, then they will work energetically, and they'll know why they're working energetically. This is how we can probably surmise the Great Pyramid was not built by slaves. I mean, when Qin Shi Huangdi forced slaves to build his Great Pyramid, as soon as he died, they quit. You know, so why did they keep building the Great Pyramid of Egypt? They did it because they were engineers and they cared, and they knew that there was something interesting happening here, and Birkeland found out that these currents coming from the poles were going to the 30-degree latitude on his planetary Torella. So he spent his time down in Egypt, and what's at 30 degrees? The Great Pyramid. And it had a cap that was electrum, and it was clearly an electrical power plant. So, this was a labor of love in engineering, business, and art. In a fully PEM, they should be related to each other and unified together in a PEM-based society. And that's what we had in the late 1800s and the early 1900s, all the way up through, the beautiful science fiction of the 1960s and 70s. That was the hopeful science fiction, right? It was the Arthur C. Clarke kind of stuff, and it was all based in this understanding that this force was going to take us places, and it will. It's just that right now we're kind of I don't know, mass delusion. I don't know what you would define it as.
It went off
but there's
the radar.
pockets.
We're just on the downside of the cycle. We're on the downside of the cycle.
It went off the radar screen in 57. It went black.
Maybe that's what happened. Maybe it's the CIA. Maybe they decided, okay, we have enough. The people have been going on with the FBI stole Tesla's work, and that's true. The FBI did steal Tesla's work, but I got the question for people. You may not be Tesla, but are you really incapable completely of creating your own thing? I mean, I don't think Eric Dollard ever said that he was as smart as Tesla or
No, he
Steinmetz.
never did.
And yet he accomplished.
Yes.
And so if everybody got involved, I get it. Like I have family members. They're always going to be nurses or work in restaurants or whatever. But is it really something that we can't modify our educational system to focus a little bit on this? This force that's unifying everything. I think it's important to push back.
Yeah. Dollard is on some other stuff, man. I mean, he even talks some wild stuff like he witnessed a star in a street light.
Well, I have no idea. I know that he had a bulb he has photos of the bulb, and it's basically just plasmoids inside of this bulb.
Is it red?
Yeah.
Yeah, I have that picture. Yeah. That's real? I thought that was maybe Photoshop.
No, it's not Photoshop.
Oh,
but
that's
it's
a real picture. Interesting.
But again, we had crystal radios that didn't need batteries.
Right.
What the heck happened? We could do it again. If people can fall in love again, the way that they fell in love after Edison, put out the light bulb. The whole world fell in love with the electromagnetic force. And we still have vast continents of people who are not really fully connected. Heck, some of them don't even have, indoor plumbing, let alone. And now we have a plumbing problem. We need transmutation because we need to filter water in a new way. We can't afford to do it the old way because it's not getting all the meds out and all that kind of crap. So we have every incentive. But running off of fiat currency is probably not going to work because it's violating the laws of thermodynamics, and that's going to create huge problems in the economy because everything's related. That's the point I'm making, Greg. Mm-hmm. Everything is related. The PEM is not separated from the power of numbers, from the power of physics, from the power of God. All of these powers, they're actually one big flowing power, and the force is absolutely a part of that. And I think that we knew that, it was a huge deal. The cosmology that was presented in Star Wars was a huge deal because it was based in something real. It was Arthurian, and it was, it had electronics. It had all the stuff that came together. Of course, we blew up Venus. We were like, whoa, blew up Venus. It was like the best time ever, so we do it again. And now, that Hacksmith guy, that Hacksmith channel, he's quite successful making real lightsabers out of, electricity and working with plasma and all this kind of stuff. And he seems extremely happy, and his business takes off. His labs are doing well. Why? I think that there is a demonstrable connection. It's completely demonstrable. And so the areas of our society that I think are in decay are all related to our refusal to accept the truth of this force. And I'm not going to say that it's a particular astrophysicist's fault. I'm not going to be like, well, that Stephen Hawking did it or that, Einstein or whatever. I would say it was just, abandoning the tones of the Great Enlightenment, the scientific method. We had to live with Ptolemy's nonsense and Aristotle's nonsense for thousands of years.
Mm-hmm.
And now there's these people using the satellite infrastructure that goes around the planet to argue that the planet is flat. It's asinine, and we're giving a little bit too much power to that overall. And if we can, whether you're alt stream or mainstream, let's say you're alt stream and you're into crystal healing.
Mm-hmm.
When people push against that, don't use magical talk about it. Push back with fundamental physics. Use the fundamental physics of how electrons are moving in a lattice, and refute the narrative. Because crystals have demonstrable properties. They have demonstrable effects on people. So how? How?
They even have galaxy light bulbs for sale now. Unbelievable.
Galaxy? What's a galaxy light bulb do?
Well, it's you plug it into your socket, and it lights up. I'll send you a picture in chat.
Okay.
It's interesting because they probably maybe got the idea from Dollard, but follow
Maybe
that
so.
link.
A bit of
Galaxy
con
light bulb.
marketing.
It's
A
probably.
bit of con marketing, Ramon.
I see.
They're marketing a con market.
Yeah.
Yeah.
Well, I am excited about the electric car revolution. I'm not too excited about the lithium issue, but I am excited about, in general, that we're finally heading that direction. There's a lot of positives in all of that. I do hope that people are mindful, and that also all of the listeners, if you get excited by this stuff, join the fray of the research and participate in that flow. Don't just sit on the sidelines. Write papers, do research, introduce people to concepts, do that experiment that I mentioned, magnetizing a piece of metal and showing yourself that there are no magnet field lines. That's just a model. That's not how it actually works. Get intimate with this cosmology, and it will transform everything. And that's where I'll leave it.
Okay. Well, I tell you, it's been a really, really good conversation. I've enjoyed this, Ramon. Thank you.
Oh, you're welcome. And I had a good time as well. It's nice to meet you, Grouch. Although I feel like we talked before somehow.
We have.
Once again, we did. Andrew.
Okay. I'm just like man, it sounds so.
It's Greg and Grouch. Hey, that has a ring to it, Grouch. It sounds like a morning show.
Well, I don't know. Yeah.
Greg and Grouch. Yep. Well, it's been a
So when you get a chance, Ramon, there's one quick thing. When you get a chance, Ramon, I don't know whether you've heard of Greg Allison or not. He has his Greg's channel, Galactic Greg's. He's from Alabama, down near you. Him and what's his name had a chat the other week, which went like ours has this afternoon. And if you get a chance, have a listen to that when you're driving somewhere or whatever.
Yeah,
and it's very interesting because both of them, they're cutting edge. They've been in cutting edge of different things. Greg in space, space engines as he calls them, not rockets.
Cool.
And it's very interesting to listen to them both talk.
Just link it in this chat. That way I'll pick it up.
I'll find it.
Thank you.
All right, sounds good. I guess we'll part on that note then, huh?
Thank you very much, guys. And
I had a great time.
Yeah, I'll probably be dead in the morning, but I'll thank you later.
Well, I'm gonna.
Nah, you won't be dead.
I'll add a few pictures to it in the unimportant parts, and where we're not following something, and it'll be cool.
Okay.
It was a great conversation.
I hope.
I just don't know what to title it yet.
Oh, I don't know. You could title it the MEMS if you want. I don't know. All MEMSy were the board.
We had a bit of everything.
I know.
We had a bit of everything. We
See,
got
electromagnetism,
economics,
plasma,
Just call it the Plasma Electromagnetic Cosmology Podcast. I don't know.
Okay. Yeah, something. I'll
Yeah,
figure
that'll
something.
do. That'll do. My number one.
The PEM is the unified
PEM
field.
one.
It's the ether we've been looking for.
So you're saying if we connect to the PIMS, and how do we quite do that? Just real quick.
Well, I meditate and
Meditation.
I'm an acupuncture guy. I hike. I meditate. I pray. Of course, you can't help but connect every time. You have to have some calories.
Yes.
But there's other times. I mean, I literally connect. I connect my crown and move bad signals out. It's really important to control the signals of your body. It's so important. There's medical issues. It's not just thoughts. We're talking of physical generation of what's called the pulse, or my. The channels, the word for channels, there's the word jingluo, which means like channels and networks. But then there's also the word meridians, which is my. So the word pulse is my, and then its homophone means channels. That's not an accident. So to generate the signal properly in your body, you have to utilize your channels, and then your channels have to rely upon a healthy signal. And I can't tell you how many different ways I see poor signals in the body. And there's energy management techniques for a person to figure out whether they're currently figuring. There's psychological techniques, there's physical signs. That would be a very mind-blowing podcast if I were to unleash on you the everything from that medicine. Hello?
That would be awesome. Let's have that one Monday.
Yeah, that would be a pretty that'd be a pretty insane podcast.
Yeah.
But
I'm always down for talking.
Well, the only thing that worries me about it is people with low faith. When people don't believe, Jesus ran into the same thing. So, and it makes it difficult because you want to help people to increase their signals, and they have a hard time believing that a guy like me, could avoid rotator cuff surgery or meniscus surgery and all these things by just using the energy.
Yeah.
And I would be glad to talk about it. It's just that I don't know how much people will be willing to listen. If they would be willing to look at my research, then maybe they'll be closer to being able to believe. But it's pretty funny. You stick metal into somebody's body and people are like, does that do anything? I'm like, of course it does. You're sticking metal inside someone's body and their nerves are going to go crazy. What do you think? I mean, there's going to be some kind of effect no matter what.
Yeah, you have a lot of people that just think that's a bunch of malarkey.
I know they do. And it's sad because I'm like, so they're either ethnocentrists or they just have a lack of imagination. But
right. Or they're afraid.
I mean, the Chinese have an average IQ of 105, but they're just doing this thing that doesn't do anything for thousands of years. Come on now. I mean, what the hell kind of thought process is that?
Oh yeah, I've heard a lot of things about that. They built these giant ships thousands of years ago. Have you ever seen those ships?
You mean the boats?
Yeah, they look like aircraft carrier. I mean, they're just huge.
Yeah, they're huge.
Ancient,
but they're not scientific enough for us. It's a common bias that I run into, and it's not that I'm not willing to talk about some of the higher end, but it gets pretty, I would say, pretty soft or woo, in order to get into it, because now you're getting into the quantum, getting into entanglement and synchronicity, and it gets hard for people to imagine that you could really entangle and you can have an effect on people at a huge distance. I mean, over time and space. Just today, I was worried about a friend. He's actually the friend that called while we were on call. And, I was worried about him. And so we were doing Qigong in the Tai Chi class, and I mentioned his name. And when he started calling me. Okay, but he lives in San Diego.
Yes.
So
that's the same thing remote viewing works on.
Exactly. And
I think, yes.
Him as well.
Some people might ask, how is it that you can meditate and gain knowledge because you're only within yourself?
Well, the question is, can you call it knowledge? I don't know if I would call it knowledge. I would say,
for lack of a better word,
you can gain gnosis, but I don't know if knowledge. Yeah, wisdom, yes, but
yes, wisdom. Yeah.
Real wisdom comes with experience, but you can gain some wisdom. You can download information, but I don't know if download information is exactly knowledge or wisdom.
It's a scientific fact that meditation betters a person in many ways.
This is true, and I can explain how, but I don't know if it has anything to do with wisdom or intelligence. No, I'm tired. I gotta go to bed.
Okay, that's another show.
Yeah.
All right.
Well, thank you for your thank you. It's 4 p.m. here. I'm lucky, aren't I? It's been great.
2 a.m. here. Yeah, he's got to go to work. We got to let him go.
Have a good night, fellas.
No, thank you, Mark.
It was a pleasure.
And don't leave this one another 3 months. Hey, what do you reckon, Greg?
Yeah. No, we won't wait another 3 months. We'll get together soon.
Yeah,
anytime. I'm always ready.
It's good to hear from you again,
And I
Russ.
look forward.
All right.
And I look forward to when you're on there with Rex. The next time you're on with Rex, say, oh, you had to talk to these two fellas the other day, and there was no ads, Rex. It'll be a good one to throw it in.
All right.
All right.
Take care. Okay.
Good night.
Bye. Bye.
Bye.
Well, I hope everybody enjoyed that. That was our talk with Ramon. And I tell you, I had a really good time. That was a good discussion. I learned a lot, and I want to thank Ramon, and I want to thank Grouch for helping out on that deal. Yeah, that was a good job, Grouch. Excellent. So how you guys all doing? Let me see who we got here. It is 3:34 a.m. and all is well. The Zingster, Jasper Newcomb, No Center, No Border. And how are you three doing there? Looks like you're having a good conversation. That's all that matters. And that's about all I got on here. The Zingster, and well, we got 55 watching. I don't want to talk too long because I know if I do, I'll lose them. But I do happen to have a bonus for you. It's Chapter 4 of Worlds in Collision. Some of you might have been waiting for it, and some of you might have just been digging on that last video. I loved it. It was a great conversation. I'm looking for someone new. Raycar, maybe gone now, I don't know. Learn, share. St. Pauli girl, well, you can come in and talk if you want. We can chat for a few. I've got to close this down. Brandy was here. Awesome. I hope you're still here. Shlomo Baconberg. I don't want to forget him. Alchemy 88, very sweet, very special. Brandy, of course, very special. You're all special. And Shannon, just don't want to miss anybody. Learn, share. NDH. I think that covers it. It goes back pretty well. RW Arts. RW Arts. And that is about it. It's going back quite a ways. Okay. So we're gonna I'm gonna close this video out. We're gonna start the B. Play a song for everybody to find it and show up, and then we'll start Chapter 4. So you'll just see it. I'm just going to end this and start a new one. I think it makes me wait about 3 or 4 minutes, but it takes me that long to get everything. Yeah, you're wrong. That's what we did, man. We just let him go. It was good. Oh, St. Pauli, you're on Discord? Okay, that's cool. We'll talk for a little bit when we come back. So I'm going to end this right now. Thank you for watching, everyone. And part 2 is coming up in 3 minutes.